Give me one sec. Now, okay, I should be live. Hello, everyone. Welcome back to the stream. A few quick updates. I should really be better at uploading stuff to YouTube so that people can see those updates a bit closer to when they actually happen. But I'm late on the on uploading to YouTube as usual. So last week, we did a lot of progress on rewriting a lot of the analysis part of the compiler to prepare for incremental compilation. Because I discovered 2 weeks ago now, or was it Tuesday last week? I don't remember. I think Tuesday last week. I discovered there was an issue in the way we do importing definitions of other. Hello, how are you? So I discovered last Tuesday that there was a mistake in how I was importing the definition of things, which means I could not do proper incremental compilation. So last Thursday, which was the last time I streamed, we did a long rewrite of all of the analysis to make use to properly use a cache of definitions so that any module can access any definition regardless of the import chain. That was a big change. Since then, a few updates. I have been wondering about something, and I've asked on both Mastodon and Blue Sky, but I'm also going to ask here for people who don't follow me there. I'm interested in having some feedback on what do you think about taking some stream time to write documentation and clean the code? Because at the moment, since I don't spend a lot of time streaming, every time I stream, I try to make progress on the project as a whole, in terms of features, and try to get to something where we can iterate. But as a result, since we are not yet in the point at a place where the compiler actually works, the code at the moment is basically unreadable for anyone who hasn't followed since the beginning. So I'm kind of wondering, at some point I will have to go clean the code, write documentation, make sure things are clean, because I tend to be pretty strict on my own code when I have a lot of time, which is the case here. But I'm wondering if I should start doing this now rather than wait until we've made more progress. And the other thing is, a big thing I wanted for this project was to never write code outside of the stream, which I have done so far. No code has been written outside of the stream. But I'm wondering if just writing documentation is something I should do outside because it's less interesting to watch. At the same time, it's also part of the project and maybe should be on stream as a result. I'm not sure how to proceed there. So that's something, if you have opinions, I'm interested in. The other thing I was thinking of is maybe I'll try some weeks to do a third stream, maybe on Wednesdays, just because since I'm only streaming twice a week on the best case scenario, this week I didn't do Tuesday, it's hard to I tend to push myself and do very long streams just to make progress. And if I add more streams, I'm hoping I can keep them a tiny bit shorter. So yeah, if you have feedback on this, should I write documentation now? Should I do this off stream or on stream? What do you think of more regular streams but maybe shorter? I'm happy to hear about it, ideally on Blue Sky or Mastodon otherwise. In other news, I have until Thursday next week. I have opened a thing. I don't have the link on hand, but likewise, it's on my social media. I've opened a thing where you can book half an hour with me, basically any evening of the week next week, if you want me to give you an intuition about monads. If you're watching this, it's likely you already have an intuition about them, so it's probably not you're not probably not the target audience. But I am very tired of all the myth around monads. I am tired of people thinking they are not smart enough to understand them, and I'm tired of them being poorly explained. So I'm please book some of my time. I'm happy to go over the basics. No math, no Haskell, purely they are a practical programming thing. What are they? What purpose do they serve? And not going into details, but just giving you an intuition for them, basically. So that's open until Thursday next week. Feel free to book if there's still some room there. The link, again, will be on Blue Sky and Mastodon. And with this, for this evening, I think I want to do a tiny bit of cleanup just for myself. Specifically, what I want to do is this analysis module, which is the big file that is the root of all of the analysis phase, contains, well, a lot of code at the moment. It's currently 1,000 and almost 1,200 lines long. What I want to do is to start extracting some things that go together into separate modules where I can start cleaning them a tiny bit. What I want to start with is I have all of my, I have to scroll so much to find them, I have a bunch of functions called the resolve function. Basically, given a path in the current scope, give me some information about that thing. Is that a struct? Is that a type? Is that a function? What is it? And also a few variants that specifically expect something in the context and will throw an error if the thing we expect in the context is not what we find. And I think I want to start moving those functions in a separate module for clarity, start documenting them as well. And also, I have been using the same naming scheme for two different kinds of functions, and I want to start distinguishing them. So that's where I'm going to start this evening, I think. A tiny bit of like cleanup and documentation. Okay, with that out of the way, let's go. So I'm just going to put this here. Perfect. And come back here. So I have, the section is still labeled type resolving, but that's not entirely true. We resolve a bunch of things beyond types. I have at the core of this, this resolve callback thing, which is a bit of a tricky thing, which is basically is able to take something that may have a definition, regardless of which phase of the definition we're in, which means either it's definition of something we have not processed yet. For instance, oh, this struct that you're referencing is in this very file and we have not processed it yet, or a resolved version that either comes from another module that we have imported or from this module but we've already processed it. So, and as a result, having this callback that is able to deal with either by using a type class, the analyzable type class, I'm able to write functions that are able to deal with either, regardless of whether we have already resolved the thing or not, which avoids having to do a lot of duplicated things. And of course, the type class allows me to, if I need to resolve the thing, resolve it, and that's where we do cycle detection. So if a constant A needs a constant B that needs a constant A, we detect the cycle. So I want to move those functions to another file, and I want to make a distinction between the functions here that take a path as an argument. For instance, this resolve const value takes something that is a path. So we found the name foo.bar in an expression within a constant value. What does this thing point to? Can it be a constant, basically? And this is where we do this callback thing and we check that either we didn't get a definition, what does that mean, or we got a definition, what is it, and we can decide whether it is appropriate for a constant value. We have also a few others where we don't take a path info as the argument, we don't take an actual path, but we take, I think we have one so far for this. Oh no, we started writing it last time. No, I mentioned that I needed it last time because I realized that resolve struct wasn't working. Okay, we're going to have a second layer of thing where we get the name of something and we want to see if we can get the definition from it, which will be a slightly similar set of functions, but we'll have to see how we deduplicate, because that's also a thing I want to do. A lot of those functions in the resolve family of functions do the same thing over and over again. For instance, hey, we found an enum. We check that. Actually, we don't do it here. We check the number of type parameters that were given in the path, and we check that it is 0 because enum do not take type parameters. For structs or for functions, we check that the number of arguments matches the number of arguments expected, or 0 for type inference, but not any other number. And those checks are duplicated in all of those functions, which is why I want to isolate them, deduplicate some of the logic. So in our analysis folder, I think I want just to do a resolving resolve. How have I named things here? I have diagnostic, monad, resolving. Sounds good. And we're gonna move. So first, I'm gonna here Maybe context rather than resolving. Scope. I feel like resolving focuses on the kind of operation rather than on the. Yeah, I don't think resolving is a good name. Naming things is hard. But there's also a good opportunity to think about, like, okay, someone who looks at the code, they see this file, what should they think about it? Should I name this definition? Because it is about finding the definition of things as part of the analysis process. Maybe definition is better. But I think context is better overall, because this is about extracting information from the context. So, and as a result, I guess this file could be the one in which I put all functions that deal with extracting things from the context, from the scope. So it's going to be context instead. So let me instead go here. And rename it from resolving to, we said context. Oh yeah, I did that thing last time as a joke. I made my prompt a fake Windows prompt just for the joke, and I completely forgot to remove it. So this file no longer exists, but now context, okay? And I am going to move all of this section. And I'm probably gonna leave some of the like substitute types. Substitute types might actually be required as part of the, yeah, okay, I'm gonna take it with me. But set type parameters and type diff and type matches should, I believe, stay in this module. They are not related to extracting stuff from the context, which makes them part of this group. Yeah, that's not the best, but it will do for now. Let me zoom this out a tiny bit just for me to be able to see the whole thing. If it's too small, let me know. I'm happy to zoom it back. And for now, even though that's going to give me a lot of errors later on, I'm just going to copy all of this, minus context, of course. That way I have access to everything those functions had access to, and some. There's probably going to be a bunch of those imports not required, but we can clean them when we get there. Okay, so I think I want to, again, as discussed earlier, I want to take this opportunity, I think this evening, since I'm doing cleanup, to actually write documentation. So I'm gonna, I think, start writing documentation for all of those functions so that I can, afterwards, figure out what they do. I think a big thing of moving to a separate module, resolve path will no longer be exported from this module, will be an internal implementation detail of this, like resolve callback is. Because this is about like giving a callback and deciding what to do, and this is purely about the internal mechanism of doing this resolution thing. Okay. So, but that doesn't mean we shouldn't document it. I think this should be documented as well. So what do we do here? We look at the current scope for the name that was given to us, this path info here. We found bar or footed bar or something. What does that correspond to? What is the thing, the role associated with that name? If there's more than one, we report an error, like, hey, you typed bar, do you mean the one from this module or the one defined in this module here? Like ambiguous error. And otherwise, we can try to do a resolve. Oh, we resolve type for the path parameters. That makes sense. So the type, if there are type arguments, we need to figure out what their types are. And then we can call the callback here. Actually, yes, we always resolve we always fully resolve the path, which means we need to always translate the type arguments as well. Okay. So this one, I think I'm going to document the top level ones instead. So let's look at an example of something that we use at the top level. I'm curious to see actually, if we try to compile right now, which ones are going to be missing. Which ones do we use actually from the other module that are going to be missing in this one? I know for a fact that resolve type is used, but what else is used in this? Like, what else can I just make completely local, basically? That is correct. I did not change the name to context here, despite renaming the file. Aha, I did not move the analyzable thing, which I think is purely an implementation detail, so that's perfect. That means I can this can move as well and will not be needed as part of this file. So, which should be documented as well. It's no longer exported. Let's see what is missing now. Ah, that is a problem. I have now a bit of a circular dependency because this logic of analyzable is, again, it's the magic behind this callback thing I was talking about, which is here, where basically all of my callback functions are able to deal with the definition regardless of whether it has been resolved or not, because if the types allow it, I can do introspection on things without actually having to resolve anything. And if I need to, I can call this analyzable thing to force the definition or force the type. But the problem is those things are defined in the analyzable module, which means I have a bit of a circular dependency. That is annoying. But I still think it's valuable to extract those things outside of the main analyzable module, so I think I'm okay with a circular dependency here, especially since it's going to be a small one. Let's go back to analysis. That's going to mean making a boot file in this. That's kind of ugly. I still think it's worth it just to follow the clarity of the files to have things separate. Unless I also move most of the analysis away from this file, which being the file that is alongside the analysis folder should just be the one that re-exports the things from the module. So maybe I should actually... Yes, I think I'm gonna move this file to the analysis folder. So yeah, again, this evening is going to be mostly cleaning up and trying to make things a bit pretty and less making progress. I'm going to move this to something named core for now, I guess. And I will rewrite a file here. It still exists, but I'm going to remove almost everything from it. Because this is basically going to be the interface of this particular folder. So I think the only thing the rest of the code cares about is analyze module. As in, given those things, give me the result. And I think it can stay that way. I think that's fine. Which means resolve module definition cache can stay here as well. and everything else can go away. Meanwhile, in the core file, this top level disappears because it is now part of the other thing. And here I just need to import core, and I might not need a lot of those other things. Okay. This one, the definition cache, will probably not be defined in this file when we're done, because it is the thing that is being used by the underlying cache across the compilation of the different independent modules. So it is defined here for now. I don't think it will remain defined here. However, resolved module and analyzed module, absolutely part of this, the interface of this thing. The analysis is this. We have already the cache of definitions. We have this other thing, which is the list of things exported by each module we have already compiled, the module name that we're currently compiling, the definition of the module we're compiling, and we output maybe a list of diagnostics if we found some warnings or some errors, and maybe the resolved version if we could finish without encountering any errors. That's the only thing that the rest of the world needs to know. Okay. So in core, we can remove a bunch of things. I almost want to keep this function here within core and just have an alias. I just re-export it from here, basically, rather than have it be written here. I don't know. No, I think this is fine. Okay, next, that means I'm gonna actually do this here so it's a bit more readable. Here, I need to do one thing, which is I need to create a core.hs/boot, which is going to be the file that allows me to do circular dependencies. And the only thing I need for my circular dependency is the analyze definition function. So everything else can go away from this boot file. Okay. Which is going to require some imports, actually. I'm going to require... I'm going to do the same, I'm going to do the same thing I usually do, which is I'm going to copy all of the imports that were required, and we'll prune them later. Okay. That's definitely a lot more than what's required. Yeah, I can already remove this for sure. Hash map, yes. Hash set as well. Built-in not required. Location required for sure. Name, I don't think it is. But tokens, yes, for identifier, perhaps. Yeah, okay. We'll figure out what's required from this afterwards. Okay. So core here now contains all of the everything that was before in the analysis module, minus what we have now moved to context. Okay. So I'm still trying to see what are the things that are required from this file. Ah, yes. This is going to be the same thing as this. So I can just do that. Not in scope, analyze definition. That is correct, which is why I'm going to need to do... Oh, this is going to mess up the whole thing, but that's fine. I need to do a source import of core. Yep, that messed up everything, but that's the price I pay for having circular imports. Okay. Because in core, here I left an import of context. There we go. Okay. So now definition is missing. That's because I have removed the AST from the imports. Maybe T. Oh, I should probably just leave the prelude, actually, I suppose. Although, was maybe T part of the... Yes, because here I'm only importing host, maybe. That's fine. I don't have any formatting on this file because it's not recognized. Name redundant, perfect. Tokens redundant, perfect. Diagnostic redundant, perfect. Okay. So those are internal functions for error handling that were defined in the one big analysis file, and now that I've moved some of the code away, they are missing from the context file. That means I think I will want... I have this diagnostic file, which contains for now just the diagnostic enum. I suppose it would not be a bad place for all like error and warning related things, so I suppose we're gonna move things there. So here, if I go back to core, again, I'm zooming out just because I'm doing a lot of like changes of big functions rather than writing individual lines. If it's too small, let me know, I'll zoom it back. So I'm missing a few functions such as report warning, report error, and handle maybe. I'm gonna move those three into diagnostic, which means I'm probably gonna need some more imports, but probably not that many. Okay, so I should probably at some point have... I don't think I want to do that now because I have this bad habit of stacking new things on top of existing things. I'm already in the process of segmenting the code. I don't want to add more. Something I will do at some point. For now, when we report an error, we only do just this diagnostic thing that contains some information about what happened and where and what kind of problem. But at the moment, it's very limited. What I will want to have at some point is to have some actual... I write it as a command for now to avoid adding more stuff on the stack. I will want to have a proper diagnostic structure which will be something along the lines of... Actually, write it with this so I have the proper formatting, and I will clean it later. Where I will have the actual like diagnostic kind, I suppose, or diagnostic info, which will be diagnostic info, which will be this thing. I will have diagnostic severity. Severity. Location is what I wanted to say, which will be a location where in the file did the thing happen, and probably some additional things such as module name of the error, and yeah, I probably want to have at least module diagnostic module, which will be a module name, which hopefully we are able to translate back into a file name or something for the error handling. Actually, the location should contain already some information about that. At some point, the location will also contain the span, which it doesn't at the moment because, again, we've done the bare minimum for error handling at the moment. But like, it will contain all of that relevant information, and I guess I would probably want... I will probably want, which means I can probably remove it from some of those things here. What top level definition were we analyzing when we encountered the error? Even if it's, rather than just saying at line 323, this thing happened, we can say in this module, while passing this function, at this line we found. So I think this would be useful to have. And I probably want to sort them by relevance, in which case it would be those two first, and then location, then diagnostic info. Okay. Except for now, I don't want to do that now because I have already too many things I'm doing at the same time. So for now, we're going to keep the diagnostic the way it is and move some of the functions here as well. Report warning, report error, handle maybe. Another thing I want to do is at the moment, too many things I want to do. At the moment, if I look at the monad that we have, there is no error handling in this. The only thing we have is we have a writer for the list of diagnostics that we have found along the way, which includes errors and warnings. What we do is, on top of this, we stack a maybe T, which is able to short circuit, basically. And we are able to unwrap it, rewrap it in a few places. We're like, okay, maybe this thing failed, but we can get the errors from this and resume with the rest of the stuff. For instance, we process each top-level declaration regardless of whether the previous ones failed, which, now that I think about it, means if we fail to process a structure A, and then we try to process a structure B that depends on A, and we retry to process A, we will fail. That's fun. In the sense of like, we're going to have the same errors twice because A had failed the first time, and now we're trying to process B, which means processing A, which means we're processing A again, and we'll get the same diagnostics. That is annoying, and maybe that means we should rethink our diagnostics to be indexed by like location or something like this, or guarantee that even in the case of an error, we put something in the cache so that we never reprocess the same top level thing. Okay, I'll think about this. Okay, next. So that's error handling. We have moved to diagnostic. So now both core and context should have access to it. So going back here, if we try to compile again, what is... Okay, so this is missing a few things because I did not import more things. I am missing, if I go here, probably just that actually. Okay, so now diagnostic compiles, monad compiles, context compiles. That's good. Well, compiles. It doesn't, but it only gives me errors for redundant imports, which tends to be the last thing that happens, because those would be warnings, and I just happen to have W error on. Okay. I'm sorry. Oh, just because, okay, of course. I still need maybe T in this thing, but I don't have the need for the other thing I was importing. Okay. Unused stop binds. Force type. That's interesting. That means I have a few things that are defined in this file that are never used, but I'm assuming that means that they are going to be missing in... Okay. So I'm going to comment everything that is, for now, never used, and we can see if it's actually never used or if it needs to be actually moved into this file. So force type never actually required. I'm going to comment this out as well. I could also try to run, it's too early in this project, but I could try to run a tool like Reader that tells me like, hey, all of those things are never used in the context of this program. Since I'm writing, there's like a library for the core thing, but the program, the compiler is a program. I could like start from the main of the compiler and check that there's no code that's never called, that there's no actually like dead code in this project. Since at the moment main does barely anything, it would flag half the project as dead code, so it's not useful yet, but it's something that will be probably useful at some point. Okay, let's comment force type. Lookup identifier, that's never used, interestingly, so maybe it doesn't belong in this file. Okay. Yeah, I think most of this file is actually never used. Resolve role is... Resolve const value, okay. I could, I suppose, rather than do this, I could what's the syntax for this? Is it options GHC, something like this? If I do a git grep options, no match. That is annoying. Do I have any other project where I've used options? I think it's options GHC. GHC pragma options. Options underscore GHC. There we go. Come on. And so here, what I can do temporarily is do not warn me for unused stop binds, because I want to see what belongs in this file and what doesn't. Okay. So here in core, we're missing lookup identifier, which is not a resolve thing, but it is using the context. So I think it belongs in this file, but probably documented differently. So I think we're going to keep it in this file. So it's going to be lookup identifier. That makes sense. Resolve const value, of course. That makes sense as well. Try resolve enum from role. That's a number that's very specific. I guess, okay, because I'm trying to think of like, okay, what kind of functions do I have in this file and how do I want to segment them? Because for now, I've been adding them kind of like randomly in my big analysis file. I want to figure out what do I need and how do I structure them? Because I have the ones that given a path info, try to find a specific thing, a type, a struct, a constant value or something. I have the try versions that are trying to see, okay, is there something with that name? And I guess I think the lookup identifier should be name with the similar like naming scheme as the try resolve enum from role. It is a try function. It's like, is there something from based on this basically? And from role, but it's still taking the path info. This function is poorly named. So I think I'm going to have the resolve and I'm going to have the lookup functions. And with the idea that resolve must succeed, but lookup might fail. I think this is the naming scheme we're going to use. Okay. Which means I think this try resolve enum from role will be instead a lookup enum. Which I think is consistent with this lookup identifier. That is not exactly correct. Because this one doesn't do, it doesn't look, I guess it does looks up an identifier, I suppose. But I think it's not looking up for a specific identifier. It's looking to see if there's something attached to it. I think lookup role would be better, as in given something that would identify a role, find this thing. And I think for consistency, it would be better if it were taking, that being said, That being said, I probably never need this specific function for anything but a straight identifier. It would be more consistent with the rest of this file if it took a path, because here what it does is create a path that only contains this identifier. So I think it should be instead, if I want to harmonize those functions and make them consistent, it should be taking this and doing, so that would be the path, lookup of the path. Okay. Which means we can already segment our file for later into lookup and resolve. Because we have lookup role. And now we have lookup enum. Okay. I'm also wondering about like where a function such as substitute types goes, because it is used within this module, but it is not specific to the process of resolving things. It's not very context dependent. It is purely a traversal of the type. So maybe this will go into a separate module as well, maybe dedicated to instantiation and type analysis. Okay. So we have the lookup. I'm going to actually use this for when I actually write proper documentation. Lookup identifier, which is now lookup role. And we have lookup enum. And now we have resolve. Okay. So we have resolve type, resolve const value, resolve value. I'm going to move those already to the top because those are internals. So we have const value, type, and value. I hope the scroll, I'm not scrolling too fast, and I hope it's not too unbearable on the stream. Okay, resolve type, which will definitely need to be deduplicated with some of the other stuff, but at least for now it's a bit more structured. Resolve value, resolve const value. Okay. What next? So we've already made some changes. So I need to go back to core and I need to replace lookup identifier. It's not a straight replacement. I need to replace that with lookup role of pure of the identifier. Like, is there already a role associated with this name? If yes, warning name shadow. Do I have any other use? Lookup root name. That's a different lookup. Lookup identifier, there we go. That's a lookup role, which likewise is just a shadow warning. I guess this is something I could extract as a function as well, potentially. But maybe not. Okay, that should be all of it, I think. I don't think there was any other lookup identifier. And I need to change try resolve enum from role as being now lookup enum. Okay. Couldn't match. Path info resolved, non-empty identifier. Oh, I suppose this is purely looking for something that is purely an identifier. So yeah, this is too much information, I think. Do I want to look up role as just being? Will I ever need, given a fully qualified path? I don't. I think I'm future-proofing something that doesn't need to. Hello, how are you? Yeah, I'm doing better, thank you. Yeah, here I think I'm future-proofing something that doesn't need to be future-proofed. Like I will never need to use this function for anything other than identifier. So I think trying to make it work on anything was a mistake. So instead I should do this, and I should go back to lookup role and just give it the identifier. Role arg name. Okay. Okay, so now what else are we missing in core? We're missing resolve struct, that makes sense. I also probably want, at the moment, I am not distinguishing in the naming convention of my resolve functions between I am resolving something that is in an expression context or something that is in a type context. And for instance, resolve struct is that am I trying to check the type of something, or am I trying to check like within an expression for, and because it's not, I don't do the same checks depending on what context I'm doing this. So that's probably something worth disambiguating as well. So I am missing resolve struct. And I think resolve struct is the one that, given a struct expression, checks that the path I have points to a struct. And I think I will need at some point another resolve struct, but for a type context where like, oh, I have, oh, sorry, I missed your question. The project about in 2 sentences. I am making a compiler. The source language that we're compiling is a made-up language that is based on Rust, but it is an extremely simplified version of Rust. The syntax is basically the same, meaning that, like, except for one thing because of a quirk of the parser, a syntax highlighting and formatting of Rust will work on our source files. Basically, same syntax, but very different meaning, because we don't have a heap, we don't have dynamic memory allocation, we are lacking a lot of things. And the reason why we have such a restricted language and such a like small language is because of what we're targeting. The target of this language is not, like, I'm not trying to compile into a binary, I'm trying to compile into an esoteric language named Piètre. And the particularity of Piètre is that it is a esoteric programming language in which the source code is an image. For instance, do I have anywhere here, I'm going to remove this silly fake Windows prompt. I think I do have somewhere in the folder of the project. This, I think. This is a valid program in Piètre, this esoteric language in which the source code is an image, that we have generated using part of the compiler, because we already have the backend part of the compiler, as in given some bytecode, make an image out of it, that already exists. This very basic program, this is the main function. This is a function that prints 2 characters. I think it prints like star and new line, and then it exits, basically. So the backend part of the compiler is already done, but now we're doing the front-end part of the compiler, as in, okay, we've parsed the language, and now we have to actually compile that. We have the AST, we have the in-memory representation of what we have parsed. We have to check that it is all valid, and then translate that into a series of instructions that we can then translate into an image. There's a bunch of different phases to this. If I go back here, the Lexer parser that's already done, as in given a big source file of our thing, we have already segmented that into a bunch of tokens. We've already transformed the tokens into an AST, an abstract syntax tree of the representation of the program in memory. We're doing the analysis, as in, hey, here you call a function foo, does that function exist? Are the types correct? And all of that, trying to resolve everything that is part of a program. When we're done with this phase, which we're not, we will then move to like lowering into an intermediary representation that is like easier to deal with, the lowering to AR, in which we will do things such as control flow analysis and so on. Then we'll do the code generation, given this new representation of the code, generate the bytecode, and then we'll have the, like, from the bytecode to make an image, which is already done. So that's a pretty big compiler project. And even though I'm targeting a esoteric language, which is not never going to be used by anyone seriously, because like, again, this is not a serious language, I'm trying to approach this project as if this were a real compiler for a real language. Of course, there are a lot of places where I'm taking shortcuts. The language is a lot simpler than a real language, for instance, but still I'm trying to make it as close to a real compiler as possible for basically this entire saga to be a like valuable experience of like what it's like to write a compiler. I'm expecting this project to like last more than a year, partly because I'm streaming on it twice a week, which means I'm not always making a lot of progress. So that's the goal of the project. This evening specifically, I'm still in this analysis phase where I'm trying to like, okay, given the thing that was passed, are the names correct? Are the types correct? And this evening specifically, I'm doing a bit of a cleanup because the analysis file had grown to be 1200 lines, and I want to segment this into smaller groups of functions in individual files to like have a bit more consistency between things. And I'm using that as an opportunity to like figure out naming and like a few cleanup things like this. So this evening is less about making progress and more about cleaning up as we go. So I am moving all of those resolve functions into this new module. I was checking that I had exported everything, and I know I haven't, but at this point I should be close to everything. Variable is scope try. I still have a try resolve. Interesting. I thought I had replaced all of them. I have renamed this function lookup enum for consistency. Okay. What am I missing? Resolve function. Okay. So that's something that is here that I'm not exporting either. That should be moved. Resolve rule is an implementation detail. Resolve function is maybe the last one? No, it's not. Definitely not. Okay. Moving those here with the rest of the functions. Okay. I forgot to export it as well. I need to export. I'm not sure there's ever one language as optimal for a thing, but yes, Haskell is definitely extremely well suited for compilers and for things like this. Like for recursive tree-like data structures and manipulating them, yeah, Haskell is absolutely perfect. The one place where Haskell might not shine is if, which is completely irrelevant for this project, if we ended up having to write a compiler that is requires extremely fast compilation time, Haskell performance is difficult. It is possible to get a lot of very good performance out of Haskell. It's not like it's orders of magnitude faster than Python, but the way laziness and memory works in Haskell makes optimizing for performance a bit more difficult. It's like there's a layer of indirection of like what you write and how it gets translated into something. That means you have to have a lot more knowledge of the language to be able to optimize for performance. So if we wanted to write something super performant that performs in like extremely limited context, like limited resources, and has to be blazing fast, maybe Haskell would not be the first choice here. Since we don't have any performance requirement, yeah, Haskell is one of the best choices. But it's not the reason why I chose Haskell. It's because it's my favorite language, basically. And also because I have a side mission with all of my streams, my Advent of Code streams and those streams, which is I want to help demystify Haskell. Haskell has a lot of like baggage. A lot of people are convinced that it's complicated of a language, that there's so many memes around it being too difficult. And I don't think those memes are true. I don't think that's true. I think it is a fairly approachable language. It has a steep learning curve at first, that's true, especially if you're coming from like imperative languages and you're not used to the weird syntax of Haskell. But I do not believe it is a particularly difficult language. It is a different language, which is not the same thing. So I'm trying the best I can to also help demystify Haskell as much as I can. As in, it is a practical language that is used for practical things. With this, I think now we are exporting everything we need. We have an unused like unused import warnings. That's perfect. Okay, unused. We like getting those errors. Non-empty, not used, context not used. What else? Okay, that should be all. Okay, so now that should almost compile, except here resolved module comes from. That means here in this thing, I don't export everything. I'm doing a thing that is fairly common where, and Rust does a similar thing. Although Rust has two different ways of doing this, Haskell has like a convention for it, which is basically if I have a folder that has a given name, like in my analysis thing, I have a folder of all of the analysis, and I have a file with the same name that is basically an interface for all the subfolder. And here I have this thing for the library, and I'm re-exporting analysis. Oh, I know why. I know why. Here in analysis, I am not exporting the constructors of this. Definition cache doesn't need to do that, but resolve module does. So now everything should compile. Perfect. So now we have split the code of the file into 2 or 3, which is a lot better. And I can go back to this file and start doing a tiny bit of cleanup, commenting, and renaming. So we have only 2 lookup functions, but that's fine. What are we trying to locate here? This is a lookup role, and I guess because that's the thing we end up finding. Any item in scope matching any matching item in scope. Okay. So I have to be careful with the naming the thing here, because we have, in our context, we have 2 layers of lookup. We match a path, which is the name of something may be qualified, like a variable foo or a qualified name such as lang dot something dot something, or colon something colon something. Those are paths. And we have a first layer of lookup, which is given that path, what is in scope with that path? Because maybe there's more than one thing. If I import a function, I don't know, square root from a module and another square root function from another module, and I call square root, I need to know which one it is. And I also need to be able to say ambiguous call. So we keep a lookup, which is our scope of this path in the scope points to that thing or those things. And then we have a second layer of lookup, which is, okay, we have identified this thing and we have a role thing for it, which tells us, well, this is a top level declaration. This is a built-in type, built-in function, type parameter in the current scope, a placeholder in some circumstances. Like, what is that thing in the current context? For some of them, like a top level declaration, for instance, or maybe for a function argument or a let variable, we might be able to find an associated definition. As in, hey, that thing happens to be of type struct something or of type like built-in type something. Give me the associated definition for that thing. And that's the second layer of lookup. And here is basically we have a name in the scope, and I want to check if that name maps to an enum. However, where I have to be careful is it's not the name matches. Is it the name matches something that happens to be of an enum, or the name is the name of an enum? Because that's not the same thing. Here we do a resolve role, and resolve role is a local function here. get name. Path name resolved. Oh, okay, so it is already a resolved path. Ah, but I don't make the distinction here. I don't make the distinction here. Okay, so it could be either. Do I want to do that? Or do I want to separate my functions into... Do I want to separate my functions into this is pointing... This is the name of an enum, or this is the name of a variable that is of type enum. Those are not the same thing. I think this is the distinction I was mentioning in my resolve functions that for now I don't have a naming scheme for. I don't distinguish between I am resolving something at a type level or I'm resolving something at the expression level. And those two things are different. And that's probably something I want to clarify. That's probably a good thing to clarify this evening, because this is a kind of bug that's lurking. Because maybe I could be thinking, oh, this type of the thing I have is an enum, so for my cast functions I can do something different, because my lookup enum said like, yeah, that's an enum. But actually it was the name of a variable whose type is enum, and my lookup enum just like found the enum and gave me that. So I think I have to be very careful, and I have to distinguish my functions between lookup of something at the type level and lookup of something at the expression level. And I might need to rewrite a bunch of things here to make sure I always have this distinction. Okay. So if I do this, what is this lookup enum? Which one is it? How am I using it at the moment? Go back to core, lookup enum. This is in the context of a expression in a constant, but this is, I have a type. Okay. So this is taking a path that points to a type. So it should already be, it is a path info resolved. Okay, so I have already resolved something as being a type. Okay. I have already resolved something as being a type. Hey, how are you? So at this point, this is purely a type level lookup. I have something that I know is a type, I already have its role, and I want to check that this thing is an enum. Okay. How do I name this? Do I say lookup enum type? Would that be a good name for this? As opposed to like look enum value or something like this? But I don't know if I will have a look enum value. But I guess like lookup struct type versus lookup struct value, I suppose. Or does a distinction only matter? If I'm looking for the definition of something, it means it's always based on the type. So basically, am I looking at something from, no, because I would have a path info in both cases, since path info is just like, this is a string and a series of identifiers that point to something. How do I distinguish between I am looking for something in the value scope or the type scope? I guess I need to check. I am fairly convinced that I will never do a lookup of something. Like I'm checking the type of, like what kind of type something is. Is it an enum? Is it a struct or something? If I have not already resolved the type of something first, which means I will, I think, never do a resolve at the type level to obtain a very specific thing like an enum or a struct, that is not on a already resolved type. I don't think that ever happens. So that means what does that mean? What that means is I'm trying to find a naming scheme to distinguish between I have this thing in my expression context and I want to check what the type is, which would be, for instance, looking that it happens to be a type coming from like a local variable or something and find the type of this expression, versus I have the name of the type and I want to check what that type is. Those are two different things. There are two different kind of operations. And I'm trying to distinguish between using enum, even though enum is not a good example. I am looking at an enum in the context of an expression. I have an expression and I want to check whether it is an enum. And I have a type and I want to check that it is an enum. How do I name this? I've already decided on like lookup versus resolve. Resolve must succeed, lookup may fail, because lookup is to check whether something exists and it's fine if it fails, while resolve must succeed. How do I distinguish between I am looking at the expression level or at the type level? I guess purely a naming thing, but lookup, type lookup? Type lookup enum is not a great function name. Or lookup enum type, lookup enum expr. Naming is difficult. I really want the name to convey what kind of logic we're performing here. Because I will probably have to rewrite this resolve role function. Where is it? Here. Because this is basically given the role of something. Like I know that in the current scope, that thing is a function argument in an expression context, or it is a top level declaration in a type context. Find the role information if I have it, well, the name of that thing if I have it, and from that do a lookup of the definition if it exists. But here, this function accepts both things that only make sense in an expression context, like a function argument or a let variable, and things that only make sense in a type context, which is, well, I guess in expression context, those also make sense. This is made more complicated by the fact that I do not distinguish in my scope between the type level and the expression level, which might be something I want to do at some point. Although at the moment, it doesn't shock me that like a function may shadow a type and the type may shadow a function. That doesn't shock me at all. Okay. So. Do we decide that the naming scheme is type of thing, context, verb? So enum type lookup, enum exp lookup, or enum type resolve, or enum exp resolve? Yeah, this language will not support dependent types. We're not gonna be doing things that complicated. Already having generic functions and like type parameters on structures is already pushing it a tiny bit. We're not gonna go all the way to dependent types. But okay, I think I'm gonna do that, which means this role lookup might stay the same without specifying, because we are looking up something based on the name. We will check both types since our scope is shared. This is going to be the role lookup. It doesn't need to specify, I think. Now, this is therefore, if we use this convention, this is an enum type lookup. Oops. Oh, because, yes, there we go. So enum is what we're looking for. We're looking at for it in the type context where we already have a resolved thing, and we're doing a lookup where it's okay if it fails. Okay? So I guess resolve type, which will become type resolve with this new naming scheme, doesn't need to specify anything because it is the default. We are looking for something at the type level. We're not trying for anything specific. It is any type resolve. So this becomes, I'm gonna just do the same thing. Otherwise, this remains. Oh, should I? Does it make more sense to have them as verb name? Yeah, I prefer having the verb first, I think. Which means let's revert this to lookup role. Oops. Naming is, of course, the most difficult part of any project. Which means this is lookup, yeah, I suppose enum type. This is at the type in the type scope, which means we're probably going to have to change this because we're probably going to have to change resolve role to be specific to the type scope. Okay, so let's keep verb first. This is resolve type, and this one doesn't need to change. Okay. Resolve const value. This one is even more specific. But I guess it matches our scheme. Resolve value, however, is not great. Why would it be an internal compiler error to find a top-level declaration when... because that means we found the top-level declaration that didn't have an associated definition. That makes sense. Okay. Okay, so in this logic, this is a resolve function indeed. And we are at the expression level, and we are looking for something that is a valid value, I guess? What does that mean? That means that this path info we've given here must be a valid expression. So it can't be a function, it can't be a struct. Oh, and that doesn't work. This function is broken already. See, that's the very thing I'm trying to avoid here. The way this function works is it takes a callback. It calls this resolve path, which is like, okay, we have this name of a thing, maybe qualified. We need to check it is a value. It is something that is valid in an expression context. And we do, okay, well, if we did not find a definition associated with it, maybe it's a function argument or a let variable. Those things are fine. They can have a they are valid in the context of an expression, provided that type checking works, of course. Therefore, we return something that succeeds. And otherwise, if we found something that has an associated definition, then, well, we can say, oh, that thing is a function that makes no sense in this context, or it's a struct that makes no sense in this context. However, where this is broken is because we have this confusion between the value level and the type level, and here this resolve path calls resolve role, and resolve role will try to see, okay, we have found the role of this thing in the context. Is it again a function argument, a top level declaration? Is it a local variable, anything like this? But we will try to do a lookup of the definition based on the type of it, which means we can find something of type struct with the definition struct despite the fact that we found it as a local variable. So this function here is wrong because it would reject a variable of type struct as if it were the name of the struct type, because we have this confusion between value level and type level. Okay. Well, I'm glad I decided to do this cleanup this evening because I'm finding a bunch of issues that I hadn't realized before. So let's clean that up. I'm gonna have to change the way the resolve role and everything works. I'm gonna have to rewrite those functions. Let's start by renaming them and then let's clean them. So this is going to be I suppose I'm going to make a distinction between expression within a constant and expression in a general case. So this is an expression value, although value makes no sense at the type level, but I want still to be a bit more specific about what we're resolving. So those things are at the value level, and I'm going to have to change my resolving internals to make sure that I don't reject things that should not be rejected. I'm going to have to rewrite a bunch of things here. So this is going to be lookup, resolve, so type level resolve. And I have value level resolve. Okay, so const value and exp value will belong to this function. Am I looking at the function? In all likelihood, this is not at the type level. But let's check. It would be in core resolve function. That is in a call expression when I'm trying to look at the expression of a function. So yes, this is basically I have found a name. I have found a name, and I must check that that name is a function. And the call expression, if I look at my AST, that's a path info. Okay, so that's a name, that's just a name, a path, a qualified path, and I have to check that this thing points to a function. I don't have function as values in my language, so I don't have to worry about like function as argument to a function or functions as a local variable. Nonetheless, this is something that at some point we could potentially support, and yeah, I'm gonna basically have to use the functions that check for things at the local value in the value scope. Okay, so this is resolve exp function. I'm gonna make sure I rename type resolve. So this is an const value, exp value, and exp function. Struct, I think, I don't remember. I think there's also going to be oh yes, that's also going to be in terms of naming. I have lookup, which is check like, is this thing in the scope perfectly fine if it fails, like if it finds nothing. Resolve must succeed. And I think I'm going to have another layer which is going to be check, which must succeed as well, but it's going to be at the type level. I already have resolved this as being a valid type. I want now to check that specifically, beyond being a type, it is a enum or a struct or something like this, which is not the same thing. And so I believe I can preemptively say that I think the resolve struct I have is a resolve exp struct. Because, if I remember correctly, this one is used. Type parameter is valid, yeah. That is because this is the one that is used for specifically a struct expression, a struct construction expression. If I go back to core and I look at resolve struct, it's not done here because this is functions and that's not done yet. It is used here, which is in the struct expression, which is within the analysis of an expression of a constant. Yeah. So it is indeed a struct resolve at the expression level. Which means I have very few things that resolve thing at the type level for now. But nonetheless, I'm going to have to rewrite some of those because they are wrong as they stand. Okay. Okay. So that's all of our functions sorted in this file. Now I have all of my internals, and I'm gonna, I think, just group together at the end. Maybe not. Maybe it makes sense to have this here as a separate thing. And then finally here the internals, the resolve callback. Okay, so what does resolve path do? And I think this might be one that I'm gonna have to distinguish between value level and type level. Because the problem is that at the moment, my scope is the same. I have like a shared scope for all the names in scope. So resolve path basically looks up. That's also poorly named. Again, the point of this evening of isolating those functions is to try to be more consistent. Here, resolve path, the path refers to the argument, while for a lot of the other resolve, the name refers to the thing we're looking for. I want to resolve this as a struct. But here, I don't want to resolve this as a path. That makes no sense. So, what is this one? This is, I do a lookup in my scope to find the role associated with something. And then, after that, I resolve the role, which is again a very poorly named thing, which is this big thing that ends up calling the callback. I actually wonder. I think, but I hope I'm not wrong about this. I don't want to make an assumption and end up changing things. I am starting to think that beyond resolve type, which is its own thing, which does a resolve path and therefore might find things that make no sense, actually all of my type level resolve will be based on I have already decided this thing is a type, and now I want to check. Which means I might not need to distinguish between the type level resolve and the value level resolve. All resolve is the part where I take a path and I want to assert that I find something at the end. And I have the check functions that like, okay, I know this is a type. I want it to be a struct. I want it to be an enum. Or I look it up as an enum. So instead of distinguishing between type and expression, I am distinguishing between lookup, check, and resolve. I think no, that doesn't work. That doesn't work. That doesn't work. And an example of this is I'm already making a mistake. This resolve exp struct is wrong. It is completely wrong. The thing here must be a type. It must be a valid type. It must be a valid struct type. So this is a type lookup. So I've just been proven wrong. Okay. So this moves to the type lookups. Because I have a name in my scope that must be a struct and cannot be a value. It cannot be a variable that points to a struct or anything like this. And if I want to be consistent with my lookup, this would therefore be lookup resolve struct type. And to be consistent, const value, exp value. Yeah, I guess that works. So this one moves here, and there is a resolve struct type. Okay, so already we're finding issues. That's good. Perfect, and I guess therefore I will have some check functions, but they will be at the type level as well. Okay. So those are at the value level. Yes. Yeah, I'm gonna keep function at the value level, although the logic of it will be similar to the type thing in the sense of like there cannot be variables with a function that doesn't exist in the language, but otherwise it behaves as a value. This is a value thing. Okay. Perfect. Analyzable doesn't change, and now I have, I think, to change the resolve role and resolve path according to what we have discussed. Substitute types probably doesn't belong here. I should probably move it to a separate module. Okay. Oops. Here. There we go. So now, this one, beyond being badly named, can it stay the same? Because I think it also suffers from the problem of it has an argument of like type resolution mode, which only makes sense if I'm looking for something that may be a type. It makes no sense if I'm trying to resolve a value. In fact, I do have that problem where like here I'm saying allow placeholder because it doesn't make sense in the context in the first place. So I should probably distinguish between I am looking for something that is a type or I'm looking for something that is I'm looking for something that is a value. Another possibility would be to express all of them in terms of no, I think resolve type needs to be this way as well. Actually, that's not true. Actually, that's not true. There's a few value level resolve function where placeholder makes sense. For instance, if I am resolving a function, do I allow placeholders in the type arguments of the function? Nope. Okay. That argument needs to be there for value level as well, even though it might just not make sense in some of them. Okay. So maybe this one is actually fine. In sense of like, I have a path. What I have to do is to translate that into a role. And to do that, I have to check in my scope, get the corresponding role, return an error, like short circuit if it's ambiguous, and make sure that every argument to in the type arguments are types. And then I get okay. So all of those, am I doing a resolve path into resolve role, or am I doing always a resolve role directly? I'm doing a resolve role directly here. Here I'm doing a resolve path, because resolve path calls resolve role. Okay. Which I think I want to change this. I want to change this entirely. The problem is that the new naming scheme means there's going to be a bunch of compilation errors, because I think this is resolve role, as in given some path info, some name in my scope, some identifier in my scope, I want to find the corresponding role of this, which would be, let's look at role, which is in the name here. Yeah, that's what it is. Except I probably don't want to just do that. Yeah, I want to return the path info. I guess it can be called resolve path then, because indeed the output is a path. Okay. But I think the difference is I do not take the callback as an argument. I do not call resolve role at the end. Instead, I return just this. Now this one is fine regardless of whether we are in a type context or a value context, because this is purely, okay, given this identifier, I have found what it is in the scope, and I have failed if it was ambiguous. Either it's not found or ambiguous. I have rejected those. I only succeed if I can say, okay, this name in the scope is this definition here or this local variable there. That's fine regardless of context, because a name could be anything if I don't have more information. Okay. So now I think what I want to do is instead I want to rewrite this resolve role function to be resolve value or resolve type, basically, as in do a look after doing a resolve path, getting the role of the thing. I want to check whether it is a value or a type, which is basically the same thing. The only difference will be what does the definition mean in that context. Although I guess I can always do the same kind of. Can I use this in both contexts, basically? And can I then filter, rather than filtering, like saying, oh no, type must be this, can I instead. No, I think it's better, rather than duplicating a bunch of checks in all of my value or type resolving functions, I think it's better to have a resolve value, resolve type here that will actually filter based on the role, which means I don't have to do that afterwards. That's a lot of duplicated code removed. Now the question is, how do I call those? And I guess resolve type is already something I have. But could I rewrite resolve type to just be that, basically? No, I can't do that. So maybe since those are internal functions, I can get away with naming them slightly differently. Resolve path still makes sense, I think. So what I'm trying to do here, the thing is I don't know what I'm trying to resolve, because here I'm trying to name the resolve function based on what they return. So resolve enum will give me an enum, resolve path gives me a path. Here it depends on what the callback I give to this function is. So this is purely a helper function. I guess since they take a callback, I can use a naming convention. This can be resolve type with, and I will have a resolve expression with. Okay, so I'm going to copy and paste this function. Actually, I'm going to use value since I have, well, I've used exp and const. Yeah, exp. Okay. So now this indeed takes the resolved path info that we have. So it's the role as an argument. And now we're trying to check that this is a type and the callback will be called. The only downside is I'm going to have, in all of my callbacks, I'm going to have a bunch of dead branches based on whether the argument is, and unless for a type I don't have to check the role. It's only for a value where I'm going to have that problem. Dead branches are not, like, internal compiler error branches, unreachable branches, not the end of the world. Would be better if we could avoid it, but not the end of the world. Okay. So what I'm doing here in the case of a type is I try to get the name, which I think should be, yes, so the unique name that uniquely identifies something in the scope of a program. So usually the top level declaration name, basically, the symbol name of the path. Okay. If it's not found, what does that mean? It could be a type, because type parameter and placeholder do not have, and built-in types at the moment do not have definitions or unique names. Why doesn't... I guess it has a unique name, but it doesn't have a definition, I suppose. Okay, but this branch makes sense. If we did find a name, if there is an associated definition with that thing, and it is a type because here we're going to reject all the ones that are wrong, then callback, okay, resolve path info, just name, that's correct. And this is basically, I try to see if I find a definition in the things I have imported, in the things that have already been resolved as part of this module, or the ones that have not been resolved yet. And if I find it in none of them, then that's an internal compiler error. It means my dependency cycle analysis was wrong and did not detect the error before. Okay, so that's correct, I think. What needs to change is this, because this is no longer okay. If I am trying to resolve something as a type, it cannot be a built-in function. That makes no sense. So here, this must be, which means I will want to rewrite this get name into a case, because this has to be a monadic action because it might fail, which means all of the others, this is pure because we don't do anything in this case. I'm going to put pure everywhere for now. And in this branch, report error. And the error here, if I go back to diagnostic, will be I have a few like this, not a type, not a constant, not a struct, not a value, not a function. I guess not a type is what this is. This is error not a type, which takes the path and the role. Do I have the path? What's path in this context? That's not path info, it's path. What is path in this context? Is that not defined anywhere? Fascinating, because this compiles. Where is the definition of path coming from, then? Huh. No. Because if I remove this one, I'm going to find a bunch of things that I want to find. Fascinating. Okay, let's look at monad quickly. Let's see. Where am I importing something? Oh, wait. I know exactly what this is. I'm doing a git grep. The problem is not all files are in my git yet, because I have created a bunch of files, so I need to add those 3 here. And now I'm certain that the git grep is gonna find path. It finds more, but it still doesn't find the declaration of path. Fascinating. Is that something I have that comes from somewhere else? What would path be? So if I do this, I'm gonna find, yeah, too many things. So I must have a type alias somewhere. There we go. Why did it not show up in the git grep? That's fascinating. Or did it? No, it should show up in the... Oh, because I'm an idiot. I am not at the root of the project. And now if I do this, of course it shows up immediately. Okay, that's just me being an idiot. Okay, that's fine. So it's just a non-empty list of identifiers. Okay, so that's basically, I suppose that in the... Yes, when the part of a path info, yes, it is a path when we are just parsed. Yes, that makes sense. Okay, so that means here, to go back here, I have this error, not a type. I need the path and I need the role. Do I still have the path? I might not, actually. Which means I might want to give that as an argument to this function as well, just for error handling purposes. Because I want to know, to report an error, under what name I found this thing that happens to not be a so original path. That's going to be a path. Okay, and here none of this changes. So not a type is Actually, I'm going to take it as an argument here so I have access to it for my errors. Case roll of. And this is the original path and the role. Okay. So a built-in function doesn't make sense when trying to look up something as a type. A function argument and a let variable don't either. Okay. So now I know that if I do a resolve type of something and the callback gets called, I know that if there's a definition, it's because I found something that is a top level declaration. And if it's nothing, it's because either I found a built-in type, which I think should have a definition. I need to work on something for them. Or it is a type parameter or a placeholder. So that's the four possible cases of resolve type calling the callback successfully. And now I can do the same thing for resolve expression with. And I guess not a value is what I want to do here. Unless I have a way, I could specify actually. I could have, that might be a better thing. I could let both of those give me a function that to, oh, and I could pre-fill the path. That would be a lot better. I could have them give me the diagnostic ahead of time, I suppose. Because the caller will know the role and will know the original path. So I can get the diagnostic as an argument. Which means here I can emit instead of another type, I can say not a struct or not an enum. Like I can already be more specific. Diagnostic, and I don't have to give arguments to this function that are only used for the purpose of creating error messages, except the diagnostic itself. Okay, I'm going to do the same thing for this one. And so here, the core of this function is going to be the same to the point where I might be tempted to extract this block here as a separate function. Because it's the same thing. What changes is the get name, basically, the implementation of get name. Because here, for get name, if I am looking at something, if I'm looking for something that is a value, it could be a function. Can it be a function? Yeah, it can be a top-level declaration. That's fine. It cannot be a built-in type. That's for certain. That would not make sense as a value. Yes, it would make sense as a value. There's no circumstance where that makes sense, which means this is a report error diagnostic. Built-in function would make sense. That's fine. Type parameter doesn't. And however, function argument and let variable are perfectly fine. And indeed, I want to get the name of the thing so I can do a lookup of the definition of the associated type. Okay. Oh, and in this case, no, I might not have a name because if the function argument is of type int, then there will not be a name associated with it. Oh, wait. That get name is the one for types, isn't it? Because the name of... Yep, it's the one for type. Oh, God. Okay. Okay, that means I need to extract those two functions as separate functions. Because here, I am looking at something in the context of an expression. So it could be a constant at the top level, a function at the top level. It could be a function argument. It could be a let variable. But if I'm doing a lookup of the definition associated with that variable, which I will want to do in some cases, then the name I need to look up for will never be a function argument or a let variable. That's never going to be the type associated with something. Therefore, it must must use the get name of types. Do I want to introduce new? Because when I have a parsed AST, a path is just a qualified or maybe not qualified name. That's just like an identifier. Do I want to introduce a distinction afterwards where something is a type or something is not a type, basically based on the role, and that way I can distinguish between the path info result that is a type and the path info result that is not a type, that is a constant like type or value at the type level, the Haskell type level, to avoid those mistakes where I call the wrong function on the thing. That would probably be a good idea. That's something we can do this evening, I think. And I think it will be worth it because I keep making that mistake all the time and it is annoying. Therefore, oh, but does that mean that the role would be different? Does that mean role would be different per... Because some roles overlap between... Because if I introduce this, I have to introduce a bunch of different types. That's going to be annoying. I guess it could be a new type wrapper on the same thing, and then I can do the same functions underneath. No, I think it's too big of a change for me to like do on a whim this evening. I'll think about it for next time. So for now, I'm just going to continue like this, which means this gets promoted to a top level function, get type name, which to given a diagnostic, which is used for better error messages, and given a role, gives me a maybe T analysis name, I think. And so this becomes get type name. Okay. And here I'm going to move it below this resolve thing here. This goes away as well. And so this would be get expression name, which has the same exact signature. And I don't need to do a case role of, I can just do a case here because the role is no longer used. This is going to be the same thing here, get expression name. Just going to align this, oops. Okay, you don't want to, that's fine. And here, there is no longer get name, this is get type name. Because here, I guess in this case, this would not be like a user error, this would be an internal compiler error if this happens, because it means we have already resolved something as a type in the context, and then we try to find the associated name and we find the function argument. That would make no sense. But I don't want to make a special case for this. So the impossible case, instead of being an internal compiler error, will report an error that is not correct to the user. That's fine with me, I guess. Okay. So we have get type name, get expression name. I can replace get type name here, get expression name here. And all of those take the diagnostic as argument. That's what it's used for. Okay. And I probably want to then, since the rest of this is exactly the same, I probably want to extract that as another function as well, which will be process callback, I suppose. What will this take? This will take, it doesn't need the diagnostic thing. It requires the path info resolved and the maybe name, I suppose. Okay. So it requires path info resolved, maybe of a name. Of course, it requires the resolve callback here. So I'm just gonna do that. And it returns, of course, the same thing that this does, which is a maybe t analysis of R. Okay. And with this, I can move basically all of that. That is process callback of callback resolved path info and name. That's just a backspace on the name. If it's nothing, call the callback as if it were resolved with the resolved path info and nothing. If the name was found, then do the lookup of the definition in all three possible locations for the definition. And if it's not found, that's an error because it's an internal compiler error. It means our cache is wrong, which shouldn't happen. Otherwise, return this action, which gets evaluated. Which I guess I could rewrite as this is a from maybe basically of yeah, this is basically just a from maybe. Okay. Which means now I can go back to this, and this is process callback, which takes the callback, the resolved path info, and the name. And none of this needs to be there anymore. And since the name is the first argument, is the last argument here, I can even do it as I can even write it point 3 almost, I think. Well, not point 3 per se, but like I can just do something like this. Or do I do it the other way around? Maybe I do it the other way around. Get type name into process callback. I need to be careful here. This is get expression name. Okay. Okay, so that definitely cleared a bunch of errors we had before at the price of more verbosity. But that's fine, I'm okay with that. Now that this is done, we do have resolve type with, resolve expression with, that are basically the same as what we had before, but now we can rewrite our other lookup functions based on this logic and fix some of the issues in them. So resolve type will be instead a resolve type with, oh, this takes to mode. No, this does not. Because all of those, oh, unless, do I want to make those two resolve functions? Because they take the path info resolved. Do I want to make them take that and basically have them call resolve path? Or do I want to have the option of, I think I want to have them separate because I will want to use those separately for in some circumstances. So no, I want them separate, which means resolve type has to be now resolved path will be resolve path of the of mode and path info. Now that it's done, I have the resolved path and I can do a resolve type with. This is the callback. And that's the resolved path. And I think that's all we need except for the diagnostic, which I can write once and for all. I think original path is only ever used for, yep, okay, so I can remove original path altogether. The diagnostic that we're going to be threading along with this resolve type with function is simply this. Oh, but this is based on... Okay, so I can't do that. Which is a tiny bit annoying. Okay. Because I was hoping to be able to reuse the diagnostic as part of this function here, rather than declaring it the same way a bunch of times, which is a bit... I guess I can make diagnostic be a function that takes the resolved path, in which case it is basically this. So it would be make diagnostic. And it takes the path name of the path info. And this would be, as a result, make diagnostic of the resolved path. Which I can then use in a bunch of places here. I can even do a just big replace. Oh, interestingly, yeah, this is not the same diagnostic, but here I can make this replace here with oops, That's not what I meant to do. I meant to do this with not a lot better, but eh. Okay. So now we've done this. We have our make diagnostic thing. We've resolved type with this callback go here. What do we do in this case? So I'm going to do this. Here, I'm going to go back down all the way to get type name. I'm going to make this a bit smaller. These are the cases where we do get a definition if and only if what we found for a type was a top-level declaration. So if we don't find a type declaration, a definition, and this is nothing case, either it means we found a placeholder, and if we are not in a context where we allow it, we report an error. Function argument we have already handled, we don't need to handle here. That's already handled by this type lookup thing. So the only other case where we have nothing is it's a type parameter, which is fine. There's no reason to refuse it. Or it's a built-in type, which is also fine. Yeah, okay. And now, if we have a definition, this is the top-level stuff where we're probably going to want to deduplicate a bunch of things for other lookup functions. But this is basically, if we find a constant that's not a type, that's wrong. If we find a function that's not a type, that's wrong. I'm not sure this make diagnostic is actually worth it. It's not very useful. What do we do in the case of a type alias? I think that's important to understand. So we force the definition, which means we will resolve the type it's pointing to, which, if it is a type alias, will then resolve that type as well. So I think we will be resolving type alias recursively because of that, I think. Let me check. What do we do in core for analyze type alias? We just do a resolve type. Okay. That means I'm expecting does this actually work? Does this actually work? I think it does, but I want to triple check. So I found a type alias when trying to resolve a type, but I want to get the actual type. So I force the definition to get the actual type alias info. Then I check type parameters, okay. And then I return the other type within. Okay. So after this, I will return the type within with the argument substituted. That's fine. But does that mean I don't think I do the resolution of type aliases recursively. I don't think I do that, and I think I should. I think a type alias should not. Wait, no, it's fine, I think. Because if I do if I force the definition of this, I redo a resolve type on the type within the type alias, which means it gets replaced by the thing it's actually pointing to. But if it were itself a type alias, then it would be doing the thing recursively. Therefore, I think it works. I think it works because it always gets replaced by the thing it's pointing to, the resolved version of it. And the resolved version of a... Yeah, no, I think that works. I think it works. I'll have to test, but I think it works. So then I can do the type parameter comparison. That makes sense. And do the type substitution. Yeah. Okay, I think this is correct. Enum, I think there's not a lot to do except checking that... Oh, that's an interesting case. For enums, actually, I have to check that the name that is given to me is not the name of the values of the enum, but of the enum itself. But otherwise, it's fine. I should do here, I should check. Which means this is something I think a lot of those cases will be deduplicated. I'm going to make functions for each of them because they happen more than once. And I will want to make sure that I do check this properly. Okay. Then, yes, okay, then I do the same thing here. In the case of a type, I always need to have... So I am doing something, I'm doing a cleanup during which I found a bunch of issues, which is often the case. So what I started with was I wanted to clean up the big analysis file, which when I started this evening was at 1200 lines, which is way too much. So what I started doing is moving all of my resolve function to a new module and start splitting it into a bunch of different modules. And in doing so, my goal was, okay, I have a bunch of those resolve functions that pass a callback that, given the role of the thing and the definition associated with it, will check whether this is correct for the current context. The problem is that I realized that I would get confused between expression level and type level in those functions. For instance, my resolve struct function, which was poorly named, and I have changed already, would look up a struct type, as in this name must be the name of a struct. However, it would accept as a valid name something that came from a local function argument or a function argument or a local variable, which means you pass a function, a variable of type struct, and then you try to construct a new struct where the code expects, therefore, the name of a struct. Then the code finds the name of a variable that happens to be of the type struct. Like, yeah, that's fine, which is not correct. So I am rewriting those functions in two different ways. First, I am harmonizing the names so that the names are consistent. Lookup are the ones that are allowed to fail. It's okay if they fail. Resolve are the ones that must succeed. Resolve are the ones that take a path info as their argument. I'll have a check thing that take an already resolved thing and do a check on that. And they always specify, when relevant, whether they apply at the type level or at the expression level. No, I'm not adding dependent types. I am not adding dependent types in this. Not yet, at least. But yeah, basically just checking that I'm resolving things at the correct scope, which means now my internal resolve functions here that do the lookup in the scope will differentiate between hey, I found the role of something and I want its name, but I'm in a type context or I'm in an expression context. And in a type context, finding a function argument or let variable will immediately result in an error. And in the same way, if I'm in expression context, finding a built-in type or a type parameter or placeholder will immediately result in an error, which means I don't have to handle those at the callback level. So now that I've done this, I'm going back over my callback level functions here, my resolve functions here, and I'm checking that they are correct with that new information. And in the process, I'm going to try to see if I can deduplicate a lot of the checks that happen on those things, because I have a lot of duplicated checks or missing checks in some cases that I want to make sure are correct. For instance, here I should do this here immediately, actually. I should get this expected length. The expected will always be 0. So I can just do actual, which is I can just actually do when the length of the parameters given here are 0, I can do a report error, incorrect type parameter count, because enums do not take type parameters. I guess I can use the actual thing just for readability. And the expected in this case will always be 0. There we go. Okay. So now what I want to check is I want to continue checking my lookup functions, and I also want to see if I can deduplicate the checks I do here when it's relevant. So next I have resolve struct type, which is this nonsense, which I'm gonna, I think, try to make a tiny bit more readable. There we go. It returns a maybe of this tuple of things, which will contain the path info, which is the full name and type parameters, the mapping struct, the resulting struct info, and a mapping of the type parameters, if any. So the thing is, now this has a lot of overlap with this function here, and I'm kind of tempted as a result to, although it's going to mean more indirections, but performance has not really been a concern so far, I could instead rewrite this resolve struct type in terms of resolve type, as in first do a resolve type, obtain the name, and then call the check function that will do something a bit similar. Because this returns the path info resolved after checking that it is a type indeed. And doing all of the checks of the type parameter count and doing substitution for type arguments, for the type aliases. Like, it does all of the work. Which means, oh, but this would force, for a struct, this would force the evaluation of a type alias. For a struct, this would force the evaluation of a type alias. Is that a problem? I don't think it is. Type aliases are always fine to resolve because they don't need to force anything else. The only thing they force definition for is another type alias, which means type aliases can be mutually recursive, which is fine, I think. So yes, it is fine to do resolve struct type in terms of resolve type. Because the way I avoid a lot of problems, I don't have to deal with this case at all. Like placeholder, type parameter, all of those are already handled for me, I suppose. Partially. They're partially handled for me. Yeah, I think I'm going to do that. I'm going to do that. It's going to add more layers of indirection. It's going to do more lookups that are not technically required, but I think it is better that way. So I will get the resolved path by doing resolved type. And resolve type doesn't take a callback. It is just the mode and the path info. So that does all of the checks on like struct definition, enum definition, all the type parameter checks, all of those checks are done. I don't need to redo them. And now I have something that I know points to a type. And I can do a resolve type with, which is why it's a bit ugly, is that this ends up doing resolve type with twice, but that's fine, I think. There we go. Yep, I think that's correct. And now in this case here, I can handle, I'm gonna rewrite it the same way, just for readability. Oh, actually, I probably don't need to. No, I need to. Because this needs to be a resolve callback. Okay. So here we have the path info, and we have maybe the definition in our callback to resolve type with. If we don't have a definition, it means we are either we have a placeholder, but in the case where they are allowed, because we've already checked that here, we have a type parameter, that's fine, probably. We have a built-in type, which would not be okay, or we have a top-level declaration, but if we have a top-level declaration, we must have a definition. We have already checked that. So here, yes, I think this is okay. I can be more explicit. So type parameter possible valid. I written nothing. I can't find information for a struct when it's a type parameter because I'm not instantiating my function yet. It's a placeholder. That's wrong here because it would be allowed by the resolve type, but here I'm saying, oh no, the name of the struct cannot be a placeholder. The placeholder is allowed within the type arguments of the struct, but the struct itself cannot be a placeholder. So that would be an error. And the only last possible case here would be a built-in type. But yeah, suppose I can just do this, and I don't have to have a catch-all case for the others to report an internal compiler error, which because this is the only possible thing here by this point is built-in type. Okay, so now when we get the definition here, we know, since we have already checked, that it is either a type alias. No, it can't be a type alias anymore. We have already resolved the type alias. We have already returned the result of what it is, so it can't be a type alias. So the only thing it can be is an enum or a struct. Anything else is impossible now, which means now I can remove all of that. I can remove that. Let's check it's the same, actually. It is basically the same, except in this case, I was calling resolve role recursively. So basically, I was doing what I'm currently doing, but with this additional layer of checking. So now it is very trivial. It is an enum that's not a struct. And I'm tempted to introduce a diagnostic thing like I've done for this one. Make diagnostic. There we go. Error another type. Oh, I almost want to. Ah, that's annoying. Yeah, stack-based languages are fun. I still want at some point to make something like based on fourth or something. Because I have never actually used fourth, but it's fun. I think Rust has like a no-alloc version where you can't do any heap allocation. It's purely stack-based, and it's fascinating that like most of Rust works as purely a no-alloc thing. Well, most of Rust. A significant subset of Rust works as no-alloc. Okay, so the thing that bothers me here, and I guess it's not the end of the world, and I guess I can simplify the code, is here, this is saying that when I try to resolve the type with here, yeah, there's the no alloc option for a lot of crates that basically like forbids memory allocation for like very specific low memory environments. I have never tried to use Rust that way. I just know it's a thing that exists. So yeah, my problem here is like I give a diagnostic here so that each function that calls resolve type with can specify, oh, it's not just that's not the type, it's like it's not a struct or something like this. But I guess the problem here is since I'm calling resolve type from resolve struct, I cannot specify this. Maybe it just means I don't do the diagnostic thing, and that's fine. Which means I can go back all the way down here. That's a pretty good project. I have never actually done anything with fourth, but if you've watched my Advent of Code streams, my made-up language on top of Brainfuck was slightly inspired by fourth. As in, the only way I make Brainfuck manageable is by using it as if it were a stack-based language, basically. And the way I started making my fake language on top of Brainfuck was basically making a bunch of macros in C++ macros that behave kind of the same way as like fourth thing, as in you declare a new thing by putting the list of the names of functions to apply on top of the stack. And that's basically is it's fourth logic, basically. We just like list the words of the functions. So here I'm going to change those resolve type with and resolve expression with. They're no longer going to be taking a diagnostic. That's a bit too bad, but so be it. And I think get expression name as a result takes the full resolve path info. And this takes... Yeah, I haven't dug into it, but I know there are some subtleties. There are some reserved keywords and stuff, but beyond that, yeah, it is extremely simple. This is also, by the way, why I like Haskell so much, is like Haskell has a lot of complexity, but the core of the language is fairly straightforward. Most of the complex things in Haskell are defined in terms of the language. So, of course, now that there's like 20 extensions in the language, it's not as simple, but Haskell without extensions, fairly simple and small language. All the interesting things are defined in the language itself. But that's partly because Haskell supports like overloading operators, which I have nicknamed more than once the curse of Haskell, because it allows you to do great things, but also it can be a nightmare. But that's the beauty of Haskell. The language is, at its core, extremely simple. Yes, absolutely. Fourth is a lot more... I hesitate to say low level, but compared to Haskell, yes, for sure. So I'm changing this. Diagnostic doesn't exist anymore. A bit. I have never tried any of those, and I really want to try that. Point 3 Haskell is great, although it's the same thing as the curse. It's fantastic to work with, probably not recommended in actual in actual code. It is a thing I try to do, a thing I've seen a lot of even experienced Haskellers do is revert to the mathematical thing of like everything is a one-letter name. For type arguments, I will do it sometimes. Like, yeah, this is the return value. It's R. It's fine, or it's literally anything. It's just A, and it's fine. But otherwise, I try to give very explicit names because I've seen people like define functions like this with like name F with C and R, and it's like, no, name things. The reverse of point 3 Haskell? In terms of like function order, yes. In terms of function order, yes. As in the function composition with dot in point 3 will be right to left, while in stack-based languages, the words will be lifted left to right in order of application. Yes, that's correct. Although you can do left to right composition in Haskell as well. There is the AND operator, which is the same thing as dollar, but the other way around, so left to right. With lens composition, it's fairly commonly done that way. And I think, let me check. Stack GHCI, it's never gonna compile, that's fine. Import control.arrow. Do I have it in scope? Oh, it's trying to compile everything. Okay, I shouldn't have done that. Import control.arrow. That's not exactly correct. The AND operator is like dollar but reverse, not like dot but reverse. However, like dot but reverse, I believe that this thing from arrow is the same thing, except it is expressed. It is expressed in terms of like highly polycandid stuff. If I set type applications and the type of this, and I give it, what would K be here? Oh, it's completely polycandid. Okay. So it would be a type, I suppose, which I might not have. Data kind type. Oh, because it's K first. K is something that combines. Oh, okay, no, okay. The first argument is the function arrow. Okay, there we go. So this thing from control arrow, which is this very complicated, arbitrarily kinded thing, in the context of functions, take a function from A to B, a function from B to C returns a function from A to C. So it is basically the oh, sorry, I missed your message about this operator. Exactly, that is exactly what it is. So basically, this one does function composition left to right, and there's also this one that does function composition right to left. But arrows are a, how do I say this? They're an area of the language that would need a bit more love, I think. Because arrows are complicated. There's special syntax in the language for them. There's like the banana brackets thing, which are like specifically for arrow expressions. Kind of like do looks are specifically, as I say, specifically for monads. They can be for applicatives with some extensions, but like the special syntax for arrows in the language, which was broken for like one version of GHCO2 and no one noticed, because arrows are not very much loved. They're a weird aspect of the language that I am not very familiar with. But yes, you can use those operators for right to left composition or left to right composition if you don't like dot. Let me close this and go back to this. I was removing the diagnostic from those functions because they cannot be given, they cannot always be given, which means I need instead, here instead of the role, I'm going to take the full path info resolved. which means here I am doing a path info. Wait, what's the AST? Path info. What's the name of the things inside that? Path name, path params. Okay. Path name of the path info. That's the part I'm interested in. Although the name is very overloaded and that's not very elegant, but so be it. And here, when I report an error, this would be error not a type with. I'm just going to do this just to avoid messing up my setup. This is the path and the role. Okay, so that's the original path. That's the original path. That's annoying. Okay. That's annoying because I will need the original path for error reporting purposes, which is a bit ugly. I'm not a huge fan of giving. Do I always have? I won't always have the original path. So maybe I should not require it in the type. Because when I do a check of like, oh, this type must be a struct, I won't necessarily have the name, the path. So I guess the path will need to be provided by, when I do proper error reporting things, it will need to be put in the context by whatever top level function is. Like, hey, this is the current path I'm analyzing or something. Okay, so I am not going to give the original path here. You can go away. Call back result path info. Get type name, get expression name. Perfect. Path goes away. And this is the path info resolved. Although I guess it could just be the role. And in here, I can do path name, and I can do the same thing here. Okay, which means here now I can go back to doing a case. And here it means I need to change. Let me do it here, diagnostic. Error another type will just be a role. Error another value will just be a role. And I guess all of the others will not take the path. And this will be provided, the path will be provided by the context when we do proper error handling. Okay. So error another type with the role, which means I need to take it as an argument to do case role of, so that I have it here as an argument. Role case role of, and now all of those diagnostic become this. And here it's going to be almost the same thing, but not quite. Not a value. Okay. Do I want to introduce a new one? Because value is more specific than expression. Because value will be used for something that, like, a function is not a valid value, for instance, because I guess at some point, if I allow function pointers and stuff, maybe functions will be valid value. Maybe value is the correct term. Okay, so value is fine. Although I have expression and value, I differentiate. I have this differentiation here. Maybe it should be value instead of expression. Yes, I think it should be that. So But I want to differentiate value in a constant and value in an expression. But that's fine, because that's still a value in the same way that this is resolve type, and this is resolve function value in the same way that this is resolve struct type. Okay. So resolve function changes name, becomes resolve function value for consistency with the rest of the naming scheme of the things around here. Did I change it in the export list? I did, okay. Which means I can change resolve expert with as resolve value with to be consistent, and get value name here to be consistent as well. Okay. There are a few places where I'm inconsistent between like name, role, identifier, path, and so on. I'm trying to like normalize things. This is why I'm doing this cleanup this evening, is to like try to clean up my resolve functions, be more consistent in my naming of them. And in doing so, I found some errors caused by the fact that I had not named them properly. So yeah, I think it's worth trying to have a proper nomenclature for naming things. Okay, so with this done, I can go back to resolve struct type, which I was doing, which is based on resolve type. So I have already checked that the type is valid, no matter what the type is. So type arguments everything that's already checked. And here I don't have to handle anything but enums. That's not a struct or a struct definition, because anything else would have already been resolved by that point. Okay. I will have to remove... I have to remove a thing. I have this make diagnostic here that is completely not needed anymore. And here, all of the errors will be just the role. So this is going to be error not a type, and the role is... It is the path name of the path. Oh, it's just path name. Path name being the role is really illustrative of some of the naming inconsistencies I have in this project. Okay, where do I have another make diagnostic? Here. Okay, perfect. I'm just gonna copy this. Okay, and next I'm going here. Perfect. So likewise, here I can remove this make diagnostic. Original path is no longer required because the path is no longer part of the error message at this point. So here, error placeholder, that's correct. Not a struct. Original path no longer required. Perfect. And here, I do not have to do the check of the incorrect type parameter count, because at this point, we will have been through a type check here. So we will not... Oh, actually... Oh no. So here the problem is, I'm going through this resolve type function first, and this resolve type function first checks that the number of arguments given to a struct is the correct number of arguments, which in the type context is required, because if a function is returning a struct, whatever it is that has type arguments, all of them must be given. There cannot be any missing one. That makes no sense. However, in the context of a struct expression, the number of arguments can be different. It doesn't have to be it doesn't have to be the exact expected number, because we support placeholder and therefore missing argument names in some contexts. Okay, so that means that this cannot be the function that is used for before I do the resolve struct type, because it is the one that is used for a type specifically, not just for a struct type in a specific case where I want a struct. And as a result, it will incorrectly reject valid expressions that we have purposefully built. So that means one of two things. That means either I cannot use this function as the base for those two, and in fact I should probably change the name of this one to be more explicit about the fact that we are resolving a type in a context in which it must be known. So resolve a concrete type, for instance, which is not always true because we sometimes allow that's my solution. I can use that because this type resolution mode tells me are placeholders allowed or not. And for a struct, the only situation where it is okay for the number of given arguments to be 0 is when we allow placeholders, which is the case here. So I can use that. Okay. That's a bit ugly. That will definitely need to be commented, I think. So here, this is when okay, I will probably need to use a helper function for this. Was this in built-in? Yes, it is here, which it shouldn't be here. Where do I use type resolution mode? Only in context. Okay, I am moving you out of here. It will be for type level resolve. There we go. And here I can probably do... So if placeholders are allowed, then in the case of a struct, I should allow a number of arguments which is 0. So which is mode. How do I write this? Do I write this as like being... I guess I'm gonna do this way. Valid will be case mode of, if we're allowing the placeholder, then to be valid, I guess invalid because it means I can use when instead of unless. When the placeholder is allowed, then that means I would allow a struct with a different number of type arguments, which means it is invalid if actual different from 0, or greater than 0, I suppose, And so there are arguments given, but actual different from expected. Otherwise, which I guess I'm going to name explicitly just forbid. So if I ever change the mode, there's no like catch-all term and the compiler will warn me. Otherwise, if the placeholder is forbidden, then it's invalid if actual different from expected. Because if we are the placeholder, 0 is a valid number of arguments. When invalid, reboot error. Okay, so now we're back here. And we will have already performed the checks, so no need to do the incorrect type parameter count. That's no longer required because that check has already been performed. And as a result, I think those two things can go away. Yep, okay, that should be fine. Okay. So now we have expressed resolve struct type purely in terms of resolve type, which means we have deduplicated all the checks here on type parameter count, and we have made sure to include a special case for when placeholders are allowed. Okay, I am gonna maybe do something a tiny bit ahead of time. I'm gonna immediately introduce another function that I don't have a need for yet, but because I know it's the next thing when I go back to doing the analysis of function, which is check struct type. As in, I have already done the resolving type ahead of time, and now I need to do this part here, like, oh, I already have a resolve type, I need to check that it is indeed a struct. Which is basically saying that I'm gonna rewrite resolve struct type in terms of check struct type. So check struct type of a resolved path. I can make it even already 0.3. It will be resolve type with go. Okay, and this will be check struct type. It will be the same type as this, except here we will have a path info resolved. And as a result, resolve struct type will be, and I can make it 0.3, it will be a resolve type allow placeholder path info into check struct type. Or if I want to do it, I've been doing it the other way around for most of my 0.3 stuff. Let's do it this way. It's gonna be that. The fish operator. We resolve the type, which is a function from path info passed to monadic path info resolved, and we give it as an argument to this function, which is the function composition in monads, basically. So that should be all. And now we have removed a lot of duplication and we have fixed several bugs, which is always good. Now, onwards to the value functions. So resolve const value. What do we do in this one? That is, we have something that must be a value in the context of a constant, which is more restrictive than a normal expression because there's a bunch of things that it must be known at compile time, basically. So here, if I look at get value name, so here this is going to be resolve value with, except no, it's not going to be that. It's going to be, I don't think placeholders makes, no, placeholders are allowed here, I think. Wait, it's irrelevant. We are not going to call this function when we know that we need a specific. No, I think they don't make sense. I think we should reject placeholders here. The only place where we're going to want to accept placeholders will be type names, but no value. I guess allow placeholder must be given for expression values, because that would include functions theoretically, even though in practice it won't. No, because function calls are resolved differently. Unless I expressed resolve function in terms of resolve value, in which case, okay, I'll get there when I get there. So for now, this is going to be the same thing as this. I resolve the path, and the mode is going to be, I think, forbid placeholder. I think it makes no sense here. Const value. And then I can resolve the type with go. I'm almost tempted, I could also rewrite those ones as being simply... This is also a simple point-free thing, I think. Because it is resolve path of the mode without the path info. Actually, am I giving the path info here? That's a mistake. This is resolve path mode into resolve type with go. I think that's correct. If it's not, the compiler will complain and we'll fix it. And I'm going to copy that, because it's basically going to be the same thing for resolve const value. Here. So this is going to be that, except the mode is going to be forbid placeholder, because we are in a const value. And this is not going to be resolve type, it will be resolve value. Okay. Original path no longer required, because all of this are just not a const. There is no need for the original path. We have removed it from the diagnostic. Perfect. So now we are in the callback here, which must be typed, hence the type here. And we arrive in this case with, if we have a definition, if we don't have a definition, what does that mean? Because there's no path here, that the only path that can give us not a definition are if get type name doesn't give us a definition. So the only three we have to handle if we don't have a definition are built-in type, type parameter, placeholder. That's easy. If we are in those situations, it means, wait, no, that's fine. Haha, this is where I'm wrong, because I am looking at the definition of the type of something, which means if I am in the case where I have nothing, it means I was in the case of a function argument or a let variable. Oh, but for the constants, those are not valid. So that's impossible. Okay, so it is still valid here. But I should not say, oh, there's no type, therefore it was a type parameter or something like this. No, it's perfectly fine. Maybe it's a variable that has a type parameter, but it could perfectly be a value. But in the case of a constant, there cannot be let variables, there cannot be function arguments, meaning if we are in the case where we didn't find the definition, it means we are in the case where it was a function argument or a let variable. Those are impossible. We could even write error, like internal compiler error here, and I might actually do that just because that's not supposed to happen at all. Which means now we always are guaranteed to have a name and a definition. In the case of a value, it means we have found a built-in function name or a top-level declaration, or we found a function argument or a let variable but in the case of a const value, that's impossible, so we don't have to handle those cases, which means we are in the case of a top-level declaration or built-in function. In the case of a built-in function, I will have the function definition associated with it, which means that here I only have to handle, I have to handle basically the definition, that's all. So type alias, not a const. Yeah, that's all valid. Here, oh no, I have to reject type parameters. I have to do that again. Do I want to do it? I think it's fine to have that duplicated because it's not a lot of code. Now that I was concerned about the duplication on type aliases, but now that's done, I think it's fine. So I think having some duplication around just that is perfectly fine. It will be duplicated. It will be there will be 3 instances of that check. I think it's not the end of the world. It's not great. It's not the end of the world. Okay. So in the case of an enum, we check that the type parameters are none because enum values do not take type parameters. Then we check that it is indeed. Oh, I could do that as when identify this report error, and then I don't have to indent this case here. There we go. Do I have the same thing here? No, I don't. Okay. Okay. That's fine, that's correct. And here I can do the same thing. Constants don't have type parameters. If we arrive here, this must be this. Okay. And now the more complicated one, which is an expression value, so a value in the context of a general expression, not just a constant. Therefore, there are more options. So if we are in the case of nothing, we did not find a definition. That means that the role was function argument or let variable, which are the cases I handle here. And all of the others will have been handled. Top-level declaration must have a associated definition. Built-in function must have a definition. The others will have been handled here. So I can no, I have to decompose this to get the variable type. Okay, but all others I can error ice, which I will need to have proper error handling for all the internal compiler errors. The thing about internal compiler errors I will really want to introduce different versions of them, because like a panic isn't great, but at the same time, that often means like, okay, we can't recover from this, we have to panic. But I will probably want to have like stack traces and things like this. And I will also want to differentiate between like this is unreachable versus like, oh, this points to a logic error there. So I will probably want at some point to go over all of those, which is why I'm naming all of them the same way. I will want to go over all of those to have a proper like name for every single thing, and have like a if like maybe have like an index into a table of a compile time check table of description for each error or something like this, because I will want to have something better than just like, oh, this something was wrong, panic. But we don't have to handle anything else because this was all handled by this. Wait, I need to change. This is this. And here I will have to allow placeholder, even though the only thing where placeholders would make sense would be for a function argument. Like function don't need to be. But the thing is, function arguments will be resolved differently, I think. Will they? Maybe not, actually. So maybe I should allow placeholder for this. Well, no, I think I shouldn't. I think I want to differentiate between this is a actual value thing that has a value versus it's a function. But functions could be values at some point in the language. I think I should allow placeholder, simply because the day I will want to allow function as values, it will make my life easier. And at the moment, it will just be a path that never happens, which is fine. Okay. Resolve path, resolve value with go. Perfect. This is all good. So we have already handled this. And now, when we find so this is where it's wrong. This is where it's wrong. Because here, finding a type alias or a function definition or something like this, it can be fine because it could be the type of the function argument or the variable, which means I have to rewrite this function altogether, because that's the I don't want to like do a Hungarian notation like maybe info, but at the same time it is true that this is like info that might not be there. I can just name it info, I suppose. Because here what I want to do is I want to do a case of the path name of, and I want to handle all of this. Because here, if it's a function argument or a let variable or anything like this, it is a valid expression regardless of its type. I don't need to check the type here. There's nothing for me to check. It makes no sense for me to reject something based on the type. That would not be logical for me to do here. The type will only matter when doing type checking at a later stage. So if I am trying to resolve a expression value and I find a function argument or a let variable, that's perfectly fine. I don't have to change anything. However, and maybe this is where I can do something different, I have to handle the only other case I haven't handled. Now there's a built-in function, I suppose, but that's going to be a problem for later. Because for now we don't support function as values. Or do I want result function to be do I want to allow function as values? I could actually do that at this point. It would be invalid at the syntax level to declare a variable as type function anyway. So it would not be possible to give functions to function arguments. It would not be possible to. If I allow functions in this specific function here, what that means is that I suddenly allow users to do let x equals some function and then use x as a function call. Basically, I let them do function aliases in functions. If I do that, I think that's fine. Since function types are not supported in struct or function arguments, it's only gonna be local uses only. Therefore, it can always be traced. There's never gonna be a problem like, oh, it's a function, but we don't know where it's coming from or what it is. It's always gonna be known within the context of a function. Wait, unless they do that in an if. I would have. Oh no! If I allow expressions of type function, even purely in a let in a actually I know how to do that. In my bytecode, a function is just a name. It's just a integer value anyway. Yeah, I guess I could allow function pointers. Which means that would be a fun exercise when we're done with the first pass of the project in months from now to add function types as valid function arguments, and suddenly we can do filter and map in this made-up language that compiles to Piètre. Yeah, let's allow functions. There is a French saying that I miss sometimes in English, like, if you can do more, you can do less. Meaning, if you're able to do more than what's required, you'll be able to do the slightly lesser requirement. So let's allow for more. So here, the one thing I want to allow that I didn't allow before is built-in function. There is currently no built-in function, but there will be at some point. And if I get a built-in function with name, I already have the name as part of the info, but I don't think I actually need it. This is nonsensical. I can remove this. If I have a built-in function with this name, I return a typed expression. Oh, for this, I would need to know the type. I would need to be able to express. I guess the type of a function. Can it be simply pointing the path that points to the function name? No, because if it is, then the type of variable that contains a function is the name of the function, which is not correct. So we would need a kind of type that is able to contain So it would need to be a built-in function type, basically. Or I guess the I guess I could introduce a new role, which is function type. Yeah, I guess I could introduce a new thing that is function type. Because I need that already. I have the problem. I am doing the thing where I'm stacking new things on top of the things I'm already doing, as usual. I could use an actual function type role because I have this problem already where when I do in this resolve function value here that I did not finish, I have the problem where I cannot return the actual resolved function info. Because if I did, then a function could not be self-recursive, or functions could not be mutually recursive, because they would need to be fully resolved before being able to, like, I would need to be able to fully resolve the function I'm calling before calling it, which means if I'm in the process of resolving a function, I can't fully resolve it to be able to call it back. So what I'm doing currently in resolve function value is to return a mock, a dummy function info resolved that contains only the information that is relevant for type checking. So basically what I'm returning is a function type. So I probably would want to be able to express a function type as a role, I suppose. That would allow me to have So I will probably want to define both a function type and a new role, which is function pointer, kinda, which is a type level role that will contain a point, like a definition of the function type without needing to do the resolving, I suppose. Because there might not be a definition that matches this one. Yeah, I think I have to do that. Although I guess it's a form of built-in type. Yeah, I kinda, but pun intended. Would that make sense? That would mean that when I resolve a type, I would need to be able to figure out, well, at this point in time, nothing will ever give me the role, nothing will ever give me the role function pointer because no such thing exists. So that's fine. Okay. Okay, so let's put this on hold for a second. Let's stack more things on top of the current project as usual. I'm gonna stack a thing, which is first, let's go, oops, that's not what I meant to do. I meant to do this. Let's go back to the AST. Let's go back to function info. There we go. And I'm gonna make, is it always gonna be resolved? I guess it's always gonna be resolved. So I don't need to like add the AST phase thing. I am gonna add a function type. Excuse me, which is purely, it doesn't have type parameters. That makes no sense. A function type will always be like known in a given context. So it is a list of function argtype, which is the argument, and a maybe type for the return value, and that's it. I don't think I need anything else. Currently, in this nonsense, what do I return? Yeah, name parameters unchanged because it don't matter. Arguments and resolve type are what matters at the end. Okay, so yes, that's correct. A function type will be a fun type args, which is going to be a list of function arg type resolve. And a fun type. I don't want to create type because it's what I've created here. I should fun return. There we go. Which is a maybe path info resolved. Wait. That's not true. That's not true. Because when we end up supporting function types as argument to functions, that will be part of the syntax of the language in some way, shape, or form. Because I don't think I want to go the Rust route of having like a fn1 straight or something like this. So I think I will want to have a built-in type, a way in the syntax to express a function type, although I don't know what this will look like yet. This means that this will be parameterized by the AST phase because we will have to parse that at compile time. So this will be either the parsed version or the resolved version. And I'm going to derive show for this. Okay. Now we have this. I can go to name. I can add a new role, which is going to be, this is neutral. This is, they're not organized in any meaningful way. That's fine. Function pointer, which is a type kind of thing. And the function pointer will have a function info, a function type resolved. Okay. That's fine, which means now that this is done, we have to come back here, we have to go back all the way down here, and we have to handle this in both cases. If we get a typed name of, if we get typed name and we find a function type, that's perfectly valid because it is indeed a type, but there, why do I have pure nothing with a dollar? I haven't run hlint in a while. I should do that this evening. It's nothing. Oh, hello everyone. Welcome to the stream. So if it is a function type, that is valid as far as types go, but that's not something we have a name associated with because there will not be any name associated with types. Hello everyone. And if we find a function type when we are looking for a value, that will not be valid. Therefore, here I can just report an error, not a value. Oh, nice. Yeah, there's a small community of us doing Haskell stuff on Twitch. Okay, now I need to go back to resolve type and I need to think about for now, since I don't know what the syntax will be for type parameter, like function types anyway, since I don't plan on supporting them, I think it's fine for this to be the way it is. I don't have to handle function types specifically. I'm sure there's more people than the two of us. But if the name of a type points to a function, that's not valid as a function type, so I can't do that. So that's fine here. So this doesn't need to change. Programming at large, I think there's definitely more. Like several friends of mine do like live code, the advent of code every now and then, and I think some of them sometimes do it in Haskell. So there's definitely more. So for people who just arrived, what I'm doing at the moment, I am writing a compiler from scratch from a made-up language that looks like Rust but is a lot simpler to an esoteric language. I'm not targeting writing a binary at the end. I'm targeting an esoteric language, specifically Piètre, a esoteric language in which the source code is an image. Here's an example of a program in Piètre that we have generated already with the backend of the compiler. Basically, this small program, like I don't have the code generation yet. I don't have the IR yet, but I already have the definition of the bytecode and how to transform the bytecode into an image. And writing the bytecode manually, I have made this small program which prints two characters and exits. It doesn't do anything interesting. The interesting part is basically translating Rust-like code, much simpler, but Rust-like code, into this. That's the thing I'm doing. And at the moment, this evening, I am still in the analysis phase. So we have passed the source code from Rust-like code. We have the AST in memory. We want to check that it's valid. We want to resolve everything. That means basically name checking, type checking. When you say like variable X, is it like, does X exist in a scope? Is there like more than one X, in which case it's an error? What type is it? Is that consistent with the types around? It is doing all of that work so that we resolve everything. We emit a translated version, a resolved version of the AST that contains all of those annotations, from where we can actually generate the IR and then do the code generation. We are still doing the analysis because it's one of the biggest parts of the whole thing. And this evening specifically, I had this gigantic analysis file that was like 1,200 lines long. The code gen part, the bytecode is already done, but actually doing the code gen from the AR, several months more work, I think, because I only stream twice a week, and I am not even done with the analysis yet. And I suspect the lowering into AR, I don't think it will take as long as the analysis, but I suspect it will be difficult, because my goal, even though I'm targeting an esoteric language, my goal with this project has been to take it as seriously as if I were writing an actual real compiler. So I've like made a progressive lowering implemented. I don't. Well, okay. Two questions there. True that sometimes it's making art and more than making something useful. It's true that this compiler will not be used for anything except generating Piètre programs, which is not useful in the grand scheme of things. I am putting, however, all of the stream archive on YouTube with the hope of like this is going to be a full thing of implementing a compiler as seriously as possible from scratch, which I hope has educational value in terms of like A, demystifying Haskell, and B, what goes into writing a compiler. For the progressive lowering, what do you mean exactly by that? Do you mean like incremental compilation, or do you mean something else? Because what I'm planning to do for the lowering into AR, I am planning to basically base the IR of this project on the LLVM IR, but being, of course, much simpler, but being on the same base. So I want a static single assignment form for the IR, and that means I'm gonna follow. I have linked in the description of the project on GitHub. I have linked the research paper that describes the algorithm I'm gonna follow for a control flow analysis to lower into AR. But I'm not sure exactly what you mean by progressive lowering. If you mean incremental compilation of like compiling each module individually, lowering into AR, into bytecode individually, and then doing linking afterwards, yes, that's already planned. If you mean something else, I am not sure what you mean. And yeah, this evening, still in the analysis phase, the analysis file had grown to be 1200 lines long. So what I'm doing this evening is I'm segmenting that file into smaller modules of related functions. And in doing so, I found some big errors. So I'm fixing them. Mainly what I wanted was to harmonize the name of a bunch of helper functions I had along the way. I wanted to deduplicate some of the checks that were performed in them. And again, in doing so, in segmenting the code, in renaming things for consistency, I found some errors. So I'm going through all of my resolve functions at the moment, which are the ones that, given some name that appears in a function or in a constant or something, like, hey, the name X appears somewhere, what is that in this context? Is that a type? Is it a function? Is it a struct? And also, given from the calling context, I want this to be a type, or I need this to be a struct. So all of those resolve functions take the name as it is given in the program and do all the necessary checks to make sure that the thing is fine. So here, for instance, I have this check struct type function that, given a type that has already been resolved, so I know I have something that points to a type, checks that beyond just being a type, it is also a struct, which means not a built-in type, not an enum at the moment. I've just added function pointers, but I think here those are not going to be... Yes, they will be handled by this catch-all case, which is fine. Not a struct, that's correct. Now for const value, here, we don't have that problem because... Oh, no, this is wrong now. I used to assume that any call to resolve value with that would give me something that doesn't have a definition would be invalid in the context of a const. No, that is still true. There is no way to have a function. It is impossible to... No, it's not impossible, actually. It is not impossible because I could use a function value. No, so like a function pointer is possible there. That being said, if I do find that, I know if I do... Ah, I see what you mean. Okay. Well, in that sense, I kind of do. There will be two stages to my lowering. At this resolving phase, where I am like doing name checking, type checking, I am already doing AST transformations as part of this. Namely, I'm doing constant unfolding at this stage as well. So I am using a Haskell technique called trees that grow, where basically all of my AST is annotated with a phase, which is either passed or resolved. And I have like type families that allow me to associate different type, so that basically the structure of the AST is the same, but some branches of the tree differ based on which phase I'm in. Currently, I have only two phases, passed, resolved, but as part of this resolving, I am doing constant unfolding, where basically anything that can be compiled at compile time, I will simplify. So the AST in the resolved form will not be exactly the same as the passed version. Then I think for the lowering into AR, I don't think I will do it incrementally. I think it will be mostly, well, unless... It depends. It depends when I actually get into actually implementing the algorithm. It will require basically doing control flow analysis. It's going to depend on how I want to define my AR and how I want to approach the problem, but I think it will be mostly one phase. I am planning, however, on perhaps having an optimization phase on the AR, where it's more obvious, given that things have been simplified, what can be removed, basically. So I don't think I'm going to do lowering in stages, but there is like definitely different phases to the process. But I don't think what I have in mind maps exactly to what you say for like progressive lowering, because constant unfolding, I think, doesn't count as lowering. Optimizations don't count as lowering, so I think, no, my lowering will be, I think, mostly one big phase. What was I thinking? Where was I back in the AST? Was there something I wanted to check? Let me think for a second. I still think this is impossible because if I ever have a function being referenced in a const, function calls are not allowed anyway, and function types are not allowed anyway. So a constant, yeah, I don't think this would work. And even if someone were to try to use a function name in a constant, it would be a function that already exists. It can't be an anonymous function. Therefore, we would follow in this case here, we would have a function definition, and we would report an error like functions calls are not allowed in constants. Okay, so that's fine. We don't have to handle anything new here. However, for expression values, this is where we have to handle something different. Because for a built-in function, if I find a built-in function, I have to resolve this as being a typed expression, the type of which maybe I'm gonna go back on this idea of supporting function pointers right now, just because I have no idea how to represent an expression of type function type. A bit of both. I have worked professionally on something that is very close to a compiler, not technically a compiler, but close to one. And I have worked on compiler projects as a hobby several times. This is my bigger compiler project for sure. So it is a bit of both. I already have some experience adjacent to compilers. I've done a lot of parsers and everything. And again, one professional project that was close to a compiler, and several hobby ones. But this is my biggest compiler project. That is both for me to like dig deeper into it, and also because like I like doing that. The thing I've done that was closer to a compiler project was a job I had which was in Haskell, which was pretty nice. We were doing a thing that translated GraphQL into Postgres or other databases, basically. Like we had different backends for the thing. So basically, given an incoming GraphQL query, parse this, analyze this, and generate the backend, which is SQL queries, and also be able to express a schema. So we had all of the parser mechanic in a not monadic way, purely applicative, so it could be introspected. So we could generate the GraphQL schema out of the parsing definition, which was very interesting to do. And that was basically, it didn't have like the former, like, it was very close to a compiler in structure, despite not being one by, yeah, it was a very interesting project. I have done a much smaller compiler in the past. I have a very small one that compiles a made-up Forth-like language into brainfuck because of course I have that. Because I like doing the advent of code in brainfuck, and writing brainfuck by hand is a nightmare. So I have made a system of like Forth-like macros, and I have a micro compiler that translates those things into brainfuck. Yeah, so I think here the problem I have is I don't know how to express a typed expression of type function pointer, basically. So I could point here, like the role here, the type would be function pointer, that's fine. But I don't know what I would put in this, basically. Oh, I guess it would simply be the path to the function. I think that would actually just be the path of the function. I have found this thing. It happens that this name happens to be, yeah, I think that's what it will be. So I think this is fine. I can try to do this. This is entirely hypothetical since there's no syntax in the language to support function type as arguments. But yeah, have a good evening. I still think it's interesting to try. So I think I'm going to do that. And here, as a result, this would be I would need, here is one of the cases where I would need to find information, as in here, if I'm in the case of a built-in function, I can do a case info of, and if I don't have any associated info, that means that somehow I found a built-in function that didn't have any associated definition and scope. That's an internal compiler error. That's impossible. I don't have proper handling for internal compiler errors yet, but for now, I'm just like panicking, but with the same message everywhere so that I can do at some later point some search and replace to actually have proper panics with backtraces and like error codes and everything. But for now, I don't. Oh, that reminds me, since there's more people at the moment, something I asked at the beginning of the stream that for which a lot of you were not there yet. I have questions for you about the way moving forward I want to continue this project. Where could one get started with compiler development? That's a very good question. I don't have a good answer. There are, I'm sure, good books and good exercises to start with. All of my experience with doing compiler things has been basically participating in projects, looking at how GHC is implemented, participating in projects and doing like learning parsers, incrementally learning the thing by doing it, basically. So I'm sure there are some good resources. I don't have good recommendations beyond trying things, basically. But I agree with you. I'm sure there are some great books about this out there. But I haven't heard about them either. So I'm sorry, I don't have a good answer there. I think this was audible on the stream. I live close to a train station, so sometimes the trains make noise. Oh yeah. Oh yes, I was saying I have a question for people still there. I asked at the beginning of the stream, but a lot of you were not there yet. I have a question regarding moving forward with the stream. I had a big goal with this project, which was to never write code outside of the stream, which is something I have managed to do so far. I want all the code to be written like live because I want to have a full archive of working on this project. But I have encountered a bit of a problem, which is since I don't stream that often, twice a week in best case scenario, I am not making progress very fast, which means when I stream, I tend to like try to make progress on features rather than spending time, cleaning the code, documenting, writing comments, and all of that. I am torn on this because on one hand, the project doesn't work yet. We don't even have a first version that we can iterate on. So trying to document things now would be a bit too early in some way. On the other hand, if someone tries to read the code as it is right now, it is incomprehensible for someone who hasn't followed. So starting to document things as I go, the code might change, the comments might change, it's fine. But there's also the question of like, would it be interesting for a stream if it's 3 hours of me writing comments, really? Would that really be interesting? I'm not convinced it would be. So I have a bit of this dilemma, or like, do I push forward with features and come back to clean up later when we have something that works? Should I spend more time cleaning now so that the code is more approachable for someone who wants to have a look now? If I start writing comments and documentation, should that be on stream because it is part of the code and part of the project, or should that be something that is off stream because that's just not something that is interesting to watch on stream? If you have opinions on this, I would be interested to hear about it, either now in the chat or on social media, on Blue Sky or Mastodon. Okay, so in the case of a built-in function, we must find its name, which we would have from here anyway. I don't actually need to check the function info, come to think of it. I think the name is enough because it uniquely identifies the function. So this would be, can built-in functions be generic? Should I have type arguments too? I guess it's just a resolved path. That's all it is. Oh yeah, no, but I need a typed expression. I need the built-in. I need the function type, and the function type can be extracted from the function info, which is what I need. Okay, so I do need here the function info, so that I can do. Will it be resolved by then? It might not be. Aha, this is the same problem. Okay, this is the same thing I was doing earlier. I have all of these resolve functions take something like resolve callback, and all the magic behind this mechanism is I want to be able to write this code here, regardless of whether the definition I found that is given to the callback here is resolved or not. Because I want to be able to look at something and like, oh, I haven't resolved this thing yet, but I know it is a struct or a function or something, and not forced resolving it. Because if I had to fully resolve something before I can use it somewhere else, recursive functions could not exist, and mutually recursive functions could not exist, mutually recursive structures could not exist, all of that. So I have this distinction of like, this definition here doesn't have to be resolved. And here, this is exactly the thing I have, the problem I have with this, where I'm gonna need to basically extract the function type for type checking purposes without necessarily resolving the full function, because I don't need to resolve the actual body of the function. So I am gonna need and I'm gonna put it here, I'm going to need a resolve function type function, the type of which will be oh, I don't know how to express this, because I don't know. It has to work for all. Okay, so I have to copy something from here. I have to copy this thing, basically. This might actually not be a resolve function, because I think it's going to be purely an internal thing. So I'm actually going to move it elsewhere when I'm done with this. So I will name it differently, because it's not going to be a resolve function, because I want the naming to be consistent across functions. This is going to be a helper that I think this is going to be a partially resolve. It's going to be a local helper function. Okay. Partially resolve function type. It will take for any AST phase P that is analyzable. Therefore, I can do analysis if required. It will take. What will I have? I will have a function info of that phase, and I will want to return this is going to be a function type resolved, where the function type will be resolved, but the body of the function will not be. And I have already done something along those lines. Oh, yeah, that's wrong. Up, there we go. So that's a function info here. I have already done something along those lines in this function I have not been over yet. So I can probably copy and paste this, and then at a later point, I will replace all of this by the new version. So this function info, I'm actually gonna deconstruct here to have access to everything that's inside. Okay, traverse, force fun arg, that's correct. Force fun type, okay. Do I want to do this check here? Or will that check already have happened before? Of expected count and given count. Will that check have already happened? No, it might not have happened, and therefore this might be the right place to do it. Okay. So here I have this logic where I am checking that the number of template arguments is either all of them or none of them. As in, if none of them are given, we can do type inference based on the type of the arguments. If all of them, or if some are given, all of them must be given. However, I think this is not true of all situations. This is only true when for function calls. For a function call, it's fine to not give type parameters because they will be inferred from the type of the arguments, or they won't be, but that's an error, that's fine. That, like, it's valid to do so, to call a function without specifying the types. If I am allowing function pointers, which is what I'm currently doing, even in a partial way, I can't do that. The type must be known when the variable is created, which means the type parameters must be known. Type parameters must be known, meaning that if I do let x equals some function, then all of the type arguments must be given. So that means I am going to need an additional argument. I'm going to use the same thing I've been using. I'm going to use this type resolution mode. Where was I? Here. To decide whether it is okay for none of the arguments to be given. If I'm in a situation where the placeholders are allowed, then it means it is okay to not give all of them. If I am not in such a situation, then all of them must be given. And I already have code that does that, which sadly is going to be a bit duplicated, but that's fine, which was this one here for structs, where it's exactly the same thing. In the context where I am initializing a struct, therefore all the fields are given, it is optional to give the type arguments. In a situation where it's in the written type of a function, it is not, the values are not given, all the types must be specified. Same logic applies here. In this here, I'm going to copy that and do this. Except this is... Actually, if I go back to function info, this is not phase dependent, so I can access this without any problem, regardless of which phase I'm in. That's fine. So this is the fun params. Oh, but I don't have the... I guess I can check that, actually. I think it's probably worth having it here, so I need the path info resolve, which is the path by which I was referring to that function, which I'm going to deconstruct here. Path info. Okay, so force fun args on different arguments. It's fine. So type, length of the function parameters, length of the parameters that were given. If we are in allow placeholder, it is invalid if it doesn't match the expected number and is greater than 0, because 0 is allowed. Otherwise, it is invalid if it is different from the expected number of arguments. Then this mapping, okay. Yeah, I should probably do this, but not here. Do I need to do this here, actually? Yeah, maybe I should need to do here. Which I guess also depends on the mode, because if any of the arguments are placeholders, I cannot register the function for instantiation. This comment, the way I'm approaching generic functions in this language, since I don't have traits, because it is a much, much simpler language, basically I'm doing the C++ approach of like kind of duck typing, in the sense of like generic functions are generic functions. Type checking is basically disabled when doing the analysis of a function. However, at each call site, I will register like, oh, this function was called with int, therefore within this module's object, we must include the compiled version of this function instantiated for that type parameter, which will be, of course, deduplicated across different modules when linking afterwards. Which means I will have to have a separate phase of like, okay, I have collected all of the generic function instantiations as part of the analysis of this module. Now I need to instantiate them, which means when I do resolving of a function type, every time I do that, if that function is not generic, I will have to register it for instantiation. And it has to be registered to do later. I can't do it on the fly, because if the function is recursive, I need to make sure it has been fully resolved first. So it's going to be the last thing. When I'm done going through the module and going through all the functions in the module and everything, I will have accumulated a list of generic functions that have been called with explicit type parameters that I must therefore instantiate. Knowing that, I need to be careful. When I instantiate some functions, it might add more things in the list of things to instantiate. So I will have to have some cache thing to avoid doing the same work twice. Okay. I think this is mostly correct, except now I have a new type function type, which doesn't have any of this. I guess the mapping I don't need for now. This is going to be needed later. I will change this function when I need it. I think the only thing I need is the resolved args and the resolved type. I think that's all. Yeah, type is fine. Except I need fun return now. I'm going to be consistent. Return. To differentiate the type of the function from the type of the return type. Okay. So that should be fine. I just need to check that force fun arg and force fun type are... they are local here. Okay. So I should probably move them to this function here, partially resolve function. There we go. Okay. Actually, do I need to do that? Or could I, since I already have a for all p here in scope, could I just do this? Because this will only be dependent. I don't need this to be for all p, because it will be for whatever was given as an argument to this function. So I think this is enough. I don't need to fully type this. Okay. Okay. What am I missing? The mapping is missing at the moment. That's fine. This function will not be here. It's going to be a purely internal helper. I'm going to move it to the internals at the end here. And now I can go back to resolving an expression value, where if I find a built-in function, then I can get, so it was partially resolve function type of my function info and the path and the resolved path, which gives me the function type. And now this typed expression will no longer have the rule built-in function. It will be replaced by a type expression, the type of which will be function pointer with the function type. Okay. Oh, and this requires the mode. And the mode here will be forbid placeholders. We want to guarantee that all the types are known. Wait, is that true? Yes, because if we are in this case, we are not in the case of a function call, we are in the case of a function expression, so a name of a function as a value, in which case we need to be able to fully know what the type is, so placeholders not allowed. So this is forbid placeholder with function expression. I'm gonna align arguments so it's a bit more readable. And we return a typed expression of type function pointer function type, and the body of the thing is a path expression that points to this specific thing. Okay. Okay. We now handle function pointers. That was not planned for this evening, but that's not a thing we do. Okay. So I still need to handle here, in this case, I'm going to do this again. Let's call this back up, go back to get name at the end here. Value name, there we go. Just so that I have the check here. So here, we have handled function argument both kinds, let variable, built-in function. Why do I have function type not a value? That's not true, I think. I don't think that's true. Wait, that's actually correct. Because I'm looking for a value. So I look at the name of something in the scope when I'm looking for a value. And that means by looking at the name of something in the scope, I found a function type. That's not supposed to happen because we don't have anything in the language that's supposed to allow this at the moment. And even if we did, that would be a type, not a value. It is correct to reject function type here. Okay. But a built-in function is fine because that's a value of type function. Okay. However, when I do a top-level declaration, when I find the top-level declaration, its type could be a function. I have to handle this. Okay. So the last thing I have to handle here is basically similar to this, which is the thing we found is a top-level declaration. So something that has a unique name, something that was declared in the specific module and everything, something that has like uniquely identified as being a declaration. Here I can do the same thing where, I don't know, way to line this like this. If there is no info associated with it, that's an error, because it's an internal compiler error, because every single declaration will have in the cache a associated definition. And here we didn't find it, that's an error. We can just panic. Otherwise, we do have the definition. And that's basically the case that was here before. Move this at the bottom of everything. I'm going to move this here and indent this accordingly. Okay. So we found a name that points to a top-level declaration. Name, the thing we found, resolved to a name of a top-level declaration. If it's a type alias, we can report an error. That's not a value. Unless we support function types, we don't support that yet. If it's a function definition, however, that now is valid because we support function pointers. So this needs to move. For a structure, report error, not a value, that's fine. But for a function now, we need to do something different. And for an enum, we're going to need to do... Okay. Is there a way... I think I'm going to have to duplicate this just because... I guess I could make a helper function for this. There is no reason not to do that, since I think the code is exactly the same here. Just check if this is urgent. I don't think it is urgent. The code is the same in here that it is in here. I think there's no difference. So since it should be the exact same, I should make helper functions to avoid having to duplicate the code here. Which means this is going to become a helper function inside here. How do I call those? Not check, because check is the name check is used for something else already. So verify enum, I suppose. And verify constant value, verify enum value. This is going to be a function that, given an enum info, and I don't need the analyzable thing because I will never need to analyze an enum. This will give me the same thing as all of the others, and the type will be a typed expression. Okay. Oh, this is not entirely true, actually. No, this is true. Okay, both of those are known at compile time. Therefore, regardless of whether I am in the context of a constant or the context of a function, rather than returning this is the path that points to that thing, I will just inline them. It will be different when I have constants that are not numeric in nature. When I add support for arrays and strings, which will be array of characters, then constants will not be inlined because I will want to instead, because otherwise it will be a nightmare in terms of code generation, I will want to instead create dummy functions that like put them on the stack, basically kind of like a strings thing in the binary. That being said, this could be done as part of the optimization on the AR. It doesn't have to be done in this phase. Anyway, for now, that's not the question, because for now, I don't have arrays and strings. So any constant would be a boolean, a character, or an int. So it's perfectly fine to inline. It's anything that's not like fit in one cell of the stack anyway. So for now, this is going to be And I'm definitely going to need more things than this. I am going to need to, at the very least, I am going to need the path info resolved. How did I call this thing so I can check type parameters and such? Okay, so it's going to be a path info. I could also decompose the enum info. Come to think of it, there's no reason not to. So it's just enum name here. It's just enum values here. And that part is the const here that goes here. So to sum up, we look at the number of type arguments that were given. If it's different from 0, well, no, I need the number here for this thing. Otherwise, I could just do a non-null. If it's more than 0, we just set it's incorrect type parameter count. We get the... I need the name as well. Name full path. Where is it defined? Oops. Name full path. That's non-empty identifier, and that's coming from... Oh, it's just okay. It is the actual path part of the name. It's not a function. Okay, that makes sense. So that means I need to have a name for this. But I know I have one, so it's fine. I can just give it as an argument to this. I'm surprised, actually, that the incorrect type parameter count uses the name. No, actually, that makes sense. I need to point to the definition, and therefore this is when calling enum thing in module foo declaration bar line 36. So it needs to know exactly what thing I'm talking about, so the name makes sense. Okay. Although I guess the path info would contain the same information. But that's less work, that's less resolving work when dealing with error messages, so it makes sense. Okay, so we get the identifier from the name, and we check, oh yes, because both the name of the enum and the values of the enum will resolve into the enum info, and I use the actual full path to disambiguate. So if it is the name of the enum, that's... Oh, I am stacking another thing on top of the other thing, as I always do. Do I check when I analyze an enum? Nope, I do not check. I do not check that the values in the enum have a different name than the enum itself. However, no, I think this is fine because I think when I look at my declarations, I think I would realize that there's more than one declaration at top level. I think this already works. Let me try. If I open this test file and I comment everything and I try to do an enum foo that contains the name foo, and I try to compile this using the pre-compiled version of the binary because I don't want to have to recompile everything. Error multiple declaration foo. Okay, so we do handle this. Perfect. So I don't have to worry about this as part of this. Okay, perfect. So that is correct. And here, if we found a name that is neither the name of the enum or one of the values within, despite the fact that it resolved to the enum, that's an internal compiler error. Okay. Now, verifying a constant value will be basically the same thing, except it will be a const info, and we might not need the name. We'll see. Verify const value. Okay. So what's this const expression here? Oh yeah, of course. I'm returning the type expression that is the result. Yes, I am forcing the evaluation of the constant. I get the resolved version of the constant, and I get the typed expression as the result of this function. Okay. And I do need the name as well, just because. Okay, and I can do. So I need. I'm going to do the same thing. Path info that I deconstruct. I need the name, and I need the const info. So I can, so path params, that's already done. Name here, and then I can do just, oh. This force definition requires the location. Interesting. That means if I need to do, if I want that, let me have a look at the definition of force definition. I think it I think it requires a with location. It's anything that is it has an is definition, and is definition enum info is the case. Okay. Ah, no, force definition doesn't take. Okay. So I need to give it the location alongside. So maybe the easiest thing to do here, the easiest thing to do is to give it with the location. Or do I decompose it anyway, since I will need to do that anyway? Maybe I decompose it. So name, location. And I don't need to decompose the const info, because what I'm going to do with it is just give it directly to this with location as an argument, except I think location will, I'll get a shadowing warning, so I'm going to abbreviate to lock, just to avoid a shadowing warning. Okay. So that's enough to do const info. So now I have verify constant value, verify enum value. Perfect. I can go back to here for constant value. I can replace all of this by this is just a call to verify enum value, and it requires the resolved path, the name, the location of the definition, and the enum info. And to be extra, I could even do that. Or I could just quit info. like I have everywhere else, and therefore save some space vertically. There we go. And this is going to be the exact same thing. Verify const value, except I think the enum doesn't actually require the location. That's only for the constant. Okay, and that is definitely a bit more concise. And we can do the same thing here. Okay. Okay. Now, is it true that... Yes, this is true. If we have a top-level declaration, we must have the definition. Not having it is an internal compiler error. That's correct. Okay. This is a thing where, like, I wonder if my type representation could be better. I have a lot of places where I do lookups and I know I must have a value because it must be in the cache. And if it's not there, there's just an internal compiler error. Could I have a better type representation that removes all of those branches? I don't know. I am not sure. Okay, so now this should be a lot better. We have removed all of the duplication. We support now function types in expressions, which is fun. And now we can do resolve function value. So I have a name that must be a function because it appears on the left-hand side of a call expression. So I have identified that my expression is a call. This like thing, parenthesis arguments. Therefore, it must be a function. So what I can do is probably reuse exp value to basically filter to make sure that the thing that I get is indeed like I can do this thing to the pre-filter, basically, that will reject a bunch of things that are not valid, which gives me a typed expression. And I can check the type of the typed expression to see that it's a function, I guess. Or maybe I don't do that and I immediately do this kind of resolve value with. Hello, how are ya? Oh, wait, there's something I'm missing actually here. This is wrong. It is now valid for a function declaration to appear as a thing for a function because we support function pointers. Yeah, I'm making slow progress, but I'm finding a bunch of issues and I'm cleaning the code, so it's still good. So here I need to handle this because I found a function name when looking for an expression, but now that we've added support, partial support for function pointers, that's valid. So what do I do in this case? Let's look at the same thing I've done here. I think that's what we need to do. I get the function type by partially resolving the function type. This is where I'm going to need the mode, because it depends on whether yes, I'm going to have to change this because it's going to depend whether I am allowing the function to be missing type arguments or to have placeholder will depend on what kind of expression I am actually If I know it's a call, then it's okay. If it's not a call expression, it's a path expression, then it's not. But as a result, that is not something I can decide at that point. Therefore, this will require the mode to be given as an argument. Did I give it as a first argument? Yes, I give it as a first argument for resolve type. So I'm going to give it as a first argument for resolve expression value. That's the mode. That's the mode. And as a result, the mode here will depend mode. Although I suppose that this can never happen. No, because I'm going to reuse this function for the other one. So that makes sense. Okay. Okay, so here, likewise, I'm using the mode. I'm tempted to see how big of a function call that is now. Should I keep it on one line? Yeah, I will. Okay. So now we have the mode so that we can decide based on how we resolve the expression whether it should allow placeholders or not. For a function value, which is specifically for a function call, so I'm going to make that as part of the name just to be very explicit, it is fine to have a placeholder. So I'm going to rewrite this as resolve value, exp value, yes, into resolve value with. So I'm doing the same resolve value twice, but it means all of the checks have already been performed. Oh, that being said, no, that doesn't work. That doesn't work because this expects a path, which this isn't. So I guess instead I can do that into a case, or rather, I'm just going to do it as a normal do block. So that's the typed expression. We have checked, and now I need to check that the type of this typed expression, the thing I have on the left, is indeed, and this is how I'm going to do it. I'm going to do it as a resolve value with, and do the same thing. Except here, I'm going to give the type of the typed expression to make sure that what I have is indeed a function type, because that's what I want to find out of this. Because for a function call, I don't need to have the fully resolved function, because otherwise recursive calls wouldn't be possible. The only thing I need is the function type. Okay, so that's the same thing, which will force me to go do a second lookup of the definition, but that's fine, that's not monstrous. Okay. And now, what do I need? Do I want the mapping as part of the function type? I don't think so. I don't think so. Wait. What am I doing? What am I doing? Because what I want to check is I want to check that this is correct in terms of types. If I do it this way, where when I have a function call, I first try to resolve the name as an arbitrary expression, I will go through this, where I will find either a built-in function or a function definition, and will return a typed expression containing a function pointer with the function type, and a path to the function. But will that be enough? I think I have no choice, because it could be it could be valid for something here to be not the name of a function, but a name of a variable that contains a function. So I should allow this. I should do it this way. However, how do I go about doing type resolution if I have placeholders? Because in this case here, or should I duplicate this function instead? Because I think I want to reuse this function. That makes sense. I don't want to duplicate all of those checks. It becomes just a check of like, okay, I have a typed expression on the left-hand side. I check that this type is function pointer, because that's basically all I need. However, what I don't know how to do is I don't know how to represent in the function info that some of the types, the type parameters, might not be present. Because when I create an expression of this, it might not be valid, but in the case of a function call, it is valid to have a placeholder, because I don't need to give type parameters for a function call when the arguments will be enough to disambiguate. So the function pointer thing must contain information. I suppose that if I allow placeholders, then I will have placeholders in the types. Okay, that's fine. That's allowed. But that means I need to know the mapping in the function info, I think. Or is that not part of the function type? I could do a second lookup rather than trying to persist information that doesn't make sense as a pointer type. As in, okay, I'm pointing to this function right there. That's the name I have found. If I do that, I'm basically bypassing. But if I, yeah, okay. What I'm thinking is, I am going to have to do a lookup of the definition of the function to be able to look at type parameters in case of placeholders to do type resolution. Now, the question is, when I do that kind of stuff, I will tend to do a mapping, which is missing here, so that I can know exactly um, the 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 types that were part of the call. So I know exactly what arguments are given. Oh, I guess it could be part of the call of the path expression. I guess it can be part of the path expression. How do I use the mapping for struct? Let's have a look at structs. I do the mapping and I return its. No, that's function info. Okay. Which is incorrect, I think. Oh no, it's the function I'm currently changing. That's fine. Okay, let's go back to structs. For structs, I do this mapping and I return it alongside it for it to be checked. So I think that's what I have to do here. Because I know the type. It has to be fully known. Oh, it doesn't have to be fully known. It can be fully known. Okay, no, I think I have no choice. I think this is a bit ugly, but I don't see any other way of doing this. So I'm going to have a look at the expression. If it's not a built-in, it's not a function pointer. If it's literally anything else after resolving the thing, then it's wrong. So if I get the function pointer, I'll get the function info. I don't care. I will, I guess. Okay, I can even do a case typed expression altogether of because the only case that makes sense would be for this to be a typed expression in which I have a function pointer and I have a path expression with a resolved name, resolved path. That's the only thing that makes sense. Anything else, and that means what we've done here is nonsense. Okay? Okay. So I will do something here. I just don't know what yet. And if I have literally anything else, I don't need to worry. That's an error. That's not a function. Okay. Do I need to do a resolve to get access to the function definition in this case? Like, oh, I have... That's not true. I might not know. Do I have the guarantee? No, I don't. In theory, the day where we support function as arguments to other functions, although we don't have the syntax for that yet, I will not know at compile time, when I'm compiling the function, what function is being given to it, because it might just be used in another module or something. So that means I cannot rely on the path expression here. That's wrong. Because it could be a function argument. it could be a function argument. And therefore I would get a path expression that is not the name of a function, but the name of the argument. So I can't do that. Okay? So that means the only thing I can check is the type, and the type must be function pointer. And I will not have access at this point to mapping of the function. So the function type needs to give me so I think I can't do that. I think I cannot abstract all of the things here. I cannot do this thing where I go through resolve exp value. I need to be able to distinguish between. Yeah, I don't think I can do that because I want to handle the case where I know what function is being called differently because I need to be able to register it for instantiation. I need to do a bunch of things differently. Therefore, I cannot call resolve x value for a function call value. That's annoying, but well, at least we arrive at the result, which is always good. So that means I have to duplicate this, I suppose. Okay. But here I can be a tiny bit more aggressive, I guess. Because here I can check that the type of the expression is function. Because again, function arguments cannot be functions yet, but at some point they will be. And as a result, I need to handle here that, oh, I got a function argument, its type must be. If I look at name. Yeah, here I can check that the archetype is correctly a function. Okay. Likewise for let variables. For built-in functions, I can then do something else. And for top-level declarations, I can do the same thing, except here I can reject with not a function. Not a function. That's the case of enums and constant as well. I don't have to handle those cases. Okay. And here is probably where things are gonna be different. Because I'm gonna have to do the resolving thing, which is where I can handle type inference. Which is the same thing I should do here, basically. Which means I should probably have another function to handle, because this is going to be the same thing in both cases, basically. I will need to partially resolve. I will need to partially resolve the function type, which will also give me the mapping that I will need. It's those cases where I will not be able to know exactly. I will not be able to know the type mapping, but in this case, if it's already in the variable or anything, the type is already known, and therefore there's no type mapping to do, there's no inference to do. Okay. Okay. So the mode here is going to be allow placeholders for this. And I think as a result, I'm going to change and have here mode be, since I'm bypassing this function, this means here this is always going to be for things that are not function calls, and therefore nothing here should ever have placeholders. So this is going to be a forbid placeholder. How did I say for constants? Forbid placeholder const value, exp value here, and I'm going to use it a few places. Mode here and mode here as well. Okay. So no mode argument to this one. And this one, however, will say allow placeholder. Okay. So I'm going to need to define a few helper functions. The first of which will be I guess I will already just call the function type handle known function, which will take the resolved path and the function info. And will be basically this case here. Handle known function. Okay. And I'm definitely going to be returning more things than just the function type. I think I'm just going to have to return the mapping as well. So this is basically going to be returning. I think this is just going to be, I don't need that. I think what I'm just going to be returning is just exactly this and nothing else. And that's going to be the same thing here. Partially resolve the function type based on what we have. We have the function info. So I don't need a helper function for this. I will need, however, a helper function for do I need to? Yeah, I think it's going to be easier if I handle this in a small helper function, which is going to be something like check function type, I suppose. Check function type. So here this will be, I have the arg type here, which will be a path info resolved. I know for a fact that this will not be the name of... No, it could be the name of a function. It could be a path of function with type arguments, actually. I can't know for sure. Actually, as part of this, when I create, let me think about this. I will need, if I want function to be given around, I will need to be able basically to uniquely identify them. I already have a things for this, which is the name, which uniquely identifies something as being it's this declaration with those type arguments. So ideally, then what should be here should be the actual name, which it isn't at the moment, because it could be a variable name or something like this. That makes sense. That just means that, like, yeah, I will need to be able to track that to a specific name. What do I want? Why do I care about this? Here, is there anything I can check about any of this? If I'm in a generic function with type arguments, whenever that generic function is instantiated, I will register the thing for instantiation. Therefore, I will have the exact name of the function in the argument. What's the difference between... Yeah, I would need to resolve the name of the name parameters to have a function. I think this will have to be done as part of the code generation. I will have to be like, oh, at this place, we're calling this with this particular set of things. This maps to this name, therefore it must be linked like this, which can be done at the code generation and linking phase. I think this is fine. I think I don't need to handle this now. What I need to handle now is the type must be a valid type expression. It must be a valid function type, basically. And I know that the mapping will be nothing. Oh. Is Twitch okay? Okay, no, I still seem to be live. Okay, Twitch told me that I was no longer live, but it seems to be fine. Okay, so here I cannot make any assumption about the shape of the thing because it could be a variable, it could be anything. I therefore have to assume that it is fully typed, fully known, because it had to be fully typed, fully known to be instantiated in the first place. Therefore, the only thing that I need to do is check the function type. That's the only thing that matters. What do I need in this case? I think I just need the archetype because I'm only interested in returning the function type, which will be the archetype if this is a function indeed. Okay. So this is going to be a check function type of the archetype. Yeah, okay, I'm starting to be convinced that this is the right approach. Archetype, var type. Even though at the moment there is no way to have function arguments that are functions. because I don't have a syntax at the moment for type functions, for function types as part of type aliases or for functions as part of function arguments. But it doesn't hurt to support this for now. Okay, partially resolve. Okay. That's fine. And the only thing I'm missing here is check function type. I have here a type as argument, which is a path. And basically the only thing I want to check is this thing I don't even need to check the thing. I can check only the path name. That's enough. And in this case, the only thing I care about is this a function pointer? Do I have to handle function pointer actually? No. It can't happen. I can't have a name that resolves to a function pointer. That's another thing. So I resolve the name. It's impossible I get a function pointer. The only thing that would give me a function would be built-in function top-level declaration. Anything else would be one of those. Function pointer is not a thing that I can obtain from resolving a name. Okay, so if I get a function pointer with the function type, then the result of this function is pure of the function type and an empty mapping because there will be no mapping. Otherwise, if the type is literally anything else, report error, not a function. Okay, and we're done with this thing except for one small thing, which is that I need to go back to, where was it? Here. And here I need to ignore the mapping that I will not need as part of this. But here I will need, and therefore I need to change this to be that. Okay. And that should be everything for this file. I think that's all we need for now. It's gonna be time after the 5 hours of working to compile all of this and see what works and see what doesn't. Oh, interesting. Fascinating. Oh, because this has changed name. This is no longer... Okay. No instance for EQ based on the function type. That's a very good point. But thankfully the function type should be fairly straightforward to... Do I have... I think path info has equality. Although I might want to do something a bit smarter there. Because the problem is I will never want to compare for equality. Why do I need equality of role, actually? Maybe I just don't need the equality of role? What happens if I try to remove that? Why do I need it, basically, is my point. Because I'm afraid of, like, if I do comparison on types, things are gonna get weird very quickly. So I don't think I should be doing equality comparisons on this. So unless I need it somewhere, I will try to not have equality comparison on this. Enum info is a type. That's because I have the wrong arrow here and here. There we go. That's fixed. Except no, because this is not a constraint. This is all types. Oh, I'm not consistent between dot align here and dot align here. I think this is better. Ah, I seem to be doing everything, the other one everywhere else. I'm doing the other one everywhere else. Okay, well, let's be consistent. Consistent is more important. Next. Same error. This is a normal arrow. Is that the only errors? That'd be fantastic. In this file, I mean. So resolve role. Oh. Lookup enum type is something I haven't done. I haven't fixed this one. So what this is I already have a type. And I want to check that its type is an enum. So what I want to do is a resolve I want to do a resolve type with that will take the name of the type and process the callback that checks that indeed this thing is an enum. Okay? So to do that, this is no longer, this is resolve type with. Does this take anything else? Do I have to say, I might have to specify whether, no, the type resolution mode is already solved by now because I already have something resolved. Perfect. So this is just a resolve type with go. Perfect. And go is this resolved callback. Where basically if I don't get I'm basically in the maybe monad, so it's fine if it fails. I am trying to see if I get a maybe definition of an enum. If I do, perfect. Otherwise there's nothing. I just return nothing. I think that's correct. There's no need to perform any checks at this point. The type has already been resolved. I think this is good enough as it is. Okay. Not in scope. Original path. Yes, I have simplified my error thing. I don't need the original path anymore. Aha. So here I have resolved path with the mode. Oh, because I have named path info here. There we go. Okay. Enum info is just info in this context, and I am certain that I have the same problem here. Info here. There we go. Fixed. Verify const value. Okay. Except verify const value not in scope. How did I name this function? I thought I had. Oh, verify constant value. No, const is more appropriate given that's the name I've used everywhere else. Let's be consistent. Okay. Same thing here. It's just called info in the scope. It's just called info in this scope. Okay, next. It's called info in this scope. What is the error here? Couldn't match typed expression. Yes, this is not the correct type. It returns this. I'm not sure I understand this error there. Because partially resolved function type with 3 arguments should give me a tuple, right? Partially resolved function type with 1, 2, 3 arguments gives me... No, it doesn't, because I forgot to add the mapping here. So that is wrong. It must return the mapping, which I can just copy and paste from the other thing, because it is this. It's a hash map from identifier to path info resolved. I'm gonna actually put it on a new line for readability. It is a tuple of those 2 things. Okay. And I need to change as well, just for readability. Here I'm going to do the same thing. I'm going to align this vertically, so it is a bit more clear that the return type is this tuple. Likewise here for readability. There we go. Okay, what next? Couldn't match. That's because that's indeed a with location, and I need to remove the wrapper of location for this, which I assume is going to be the same thing here. And it's really going to be the case in a bunch of other places. Wait, what? Oh, yeah, I suppose. I guess I could handle this. So here the problem is, like, I have something where I know that the type of the thing I got was a built-in function. So I'm expecting the associated info here, which is the name and the definition associated with it. I am expecting it to be a function info, but I can't guarantee that, which means I need could it legitimately be anything else? If I have something that is a built-in function type, no, it must be the name. If it's a built-in function, no, it has to be a resolve function info. There's no other way for this to be. Okay. So I can do this with location of a function def info, where this is the function info, and anything else is an internal compiler error, because we must, if we found a built-in function, we must have found a function definition associated with it. And so now I can just give this info. Okay, what do we have here? Oh, this is supposed to be a path info resolved. So this must be the type of this expression. The role must be the function pointer function type, but I need to also give the type arguments, if any. Because I have the resolved path, and I've decided no, actually, I know better than what the path is. So I need to create a type argument for a function there, and that must be... Or do I decide that it makes no sense to have type arguments for something that is a function pointer? Yeah, I think this is what probably makes the most sense. So this will be a path info where we have this and nothing. And the second argument will be a path expression of the resolved path. Okay? And I think I'm going to have the exact same problem here, which means I will do the same thing. And I'm just going to copy and paste. Couldn't match. Yes, at this point I have already extracted the location. I don't need to do the located info here. Well, thank you for tuning in, and I'll see you next week. So here, function type. Oh, yes, this here is again something where we have a mapping that we get to ignore in this context. Okay. Now, oh, I have path name. Wait. What? Oh, I think the problem here is I'm introducing path name of this, which means I can't do that. I need to... Because otherwise this path name is unclear. Okay. Yeah, I don't need the path name anyway. I need it here. Okay. I guess to avoid having to type a bunch of things I don't want to type, I could do this instead. And don't use path name, not use path name here, and instead just give the full type, which means that this check function type will instead will do a case of the path case path name of... Ah, come on. Sometimes stylish Haskell, despite not being very intrusive, will make weird things like this. Okay. Okay, next. This, there's no info in scope because here I named it function info. I'm going to rename it info, except this is going to be a problem. So I will instead... Oh, this is the same problem I've had ahead there, I think. This is the exact same problem I've had here. So I'm going to copy paste that. Because I believe it is the same. If I have just of a name I don't care about and a with location of a function def info, I can do just this actually. Allow placeholder resolve path info, and I can remove all of this, and otherwise, yeah, there we go. Same error as in the previous function. Okay. Couldn't match type, maybe name with name. Okay. Because this returns... Oh yeah, this returns a maybe name. As indicated by the just and nothing absolutely everywhere. Okay. We're getting close to the end of the file. Oh, function pointer, not function type. Okay. Oh, this is pure just name. This is pure just name. Okay. Here. Here I have to be explicit about the fact that this is a resolved function type, I believe. Huh. Oh, that's because here I have done a traverse of the arguments, but in the context of a function type, I do not care about the identifier, so I have the wrong shape of thing there. So I suppose I have to do a map second here. Which in turn means this is now a regular traverse because I don't have to traverse the pair anymore. Okay. So the type argument here is not required. I'm surprised. Let's see. Okay. Resolved path. Oh, that's the path here. There we go. I suppose to be consistent with what I've done everywhere else, I'm going to do the same thing. Actual is this. Okay. No instance here because I'm doing a force definition, which means I need to add an analyzable constraint here to be able to do that. And now we're done. Okay. I will remove this. Not in scope lookup enum. That's correct. It's lookup enum type now. Resolve type, resolve struct type. That's correct. And I'm also going to add check struct type, which will be useful soon. And I have resolve const value, export value, function value, export value, function call value, and everything else is internal. And I think I also want to check at some point, this substitute types thing is useful, but I don't think it should be part of this. I think it should be moved to a separate module for instantiation and for type manipulation, but I don't have such a module yet. It will move there when I have it. Unused match. That's easy to fix. So now we are at all of the warnings that I have as errors, but we are at some pretty much at the end of compiling this file. So here, this is the case where I have done... Wait, which one am I doing with? This one. Yes, this is a check struct type. So I've already resolved something as being a type. So since I have already resolved something as being a type, I know it can't be a type alias, because this has already been resolved as part of this. It has already been resolved as not being a const, not being a function, not being anything else. Therefore, the definition then must be one of those two. Anything else, if we encounter literally anything else, that means we have an internal logic error. That's not the user did something wrong, we did, and that's an internal compiler error. Okay. Next, pattern matches are not exhaustive again. No, that's another error. The binding for info shadows the existing. Oh yeah, indeed. So this is going to be the fun info. This one. Info. All of those. That's going to be a E info. This is going to be C info. And an F info. F info, okay. This is good, we are the warnings at the end, so we should not... Okay, that's an F info again. It's all of those places where I have named something info. Here name is not used, I can just... Okay, info shadow, so there's going to be an F info there again. Name, probably not used, I suppose. Archetype, not used. Which means I can also probably reduce the indentation of this. Not sure stylish Haskell will do it for me. Let's do it myself. Okay, try again. Only 3 warnings left. Defined but not use expected? What? Oh yeah. Oh yeah, it's a good point. I do the logic of checking the invalid expected and everything, but I don't actually make use of them. So, what I forgot is, if I go back to the struct one, where I do something similar. There we go. And that should be almost everything. Name is missing here. Oh, I need the name of this function. Do I have it? I don't. I don't have the name of this function, but I would have it from the context, which means I can give it here. And now I can go look at partially resolve, and it's going to be after the path info. So here I need the name, which means here I need the name. Partially resolve, I'm going to need the name here so that I can give the name here. Partially resolve, I'm going to need the name here, so I'm going to need the name here. Perfect, I already had it. And name. Name. Should be all. Hold on, scope, name. I've added it to the arguments, but I have not added it here to the list. Name, there we go. There we go, context compiles. Now, I'm gonna have to change a bunch of things in core because I have renamed a ton of stuff. First, I have forgotten to export type resolution mode from this file. Lookup enum no longer is, it's no longer its name, it is now lookup enum type. Oops, with a lowercase e. Resolve struct is no longer something that exists. It is called resolve struct type. Fun type is no longer something that exists, it's called fun return now. To avoid confusing the return type with the full type of the function, since the full type of the function has become a bit more relevant. Lookup enum doesn't exist anymore. It's now lookup enum type, since I have done a bunch of renaming. Resolve value. This is in the context of a function expression, therefore it is exp value. Resolve function call. A bunch of undefineds because that's where I was at the end of last time I worked on this. But now I have resolve function call that works, so we should be able to continue with this. Perfect. Fun type no longer exists, it is fun return. Oh, so that's there. Okay. Resolve function call. It's not called that, it is called function call value. Yes, that is indeed a function type. To do, okay. And now, whew, we're getting close to the end. Fun return is not, that's not correct. I think it is fun type return. No instance for EQ role. Haha. This is where I end up doing This is where I end up doing equal equal. This is why I need equality on roles. Is that something that makes sense? Let me think about this for a second. When I do a type diff, I do this in the context of I have vector of pair int and t being a type parameter on one hand, and I have something else on the other, and I want to be able to isolate where the things differ. So I can have a proper error of like, hey, you have int here, you have boolean on the other side, or I can try to be smart and be like, oh, there's a t thing here with an int there, therefore t must be int. To do so, I look at if the types are themselves different, like perfect. Otherwise, I assume they're the same and I look at the type parameters. However, what kind of types can I encounter when I do this? I can encounter a top level declaration or a built-in type. Or a type parameter or a placeholder. I guess now I can encounter a function pointer, which means I will need to do the diff on I will need to do a smarter diff there. Okay, so I will not add equality and order here. I think those are bad for this type. I will have instead two. What? What? Why does this require an ORD instance there? Fascinating. Because I'm applying the operator on the two things, and this only makes sense. An expression resolved can only be compared this is in a const, therefore it must be known. Yeah, okay, I'm just gonna have to write this down explicitly because that doesn't make sense to me. Okay, I have checked the types. Wait, in comparison expression, I check the types. In binary bool expression, I check the types. In binary int expression, I check the types. Why do we... What do we do with comparison expression here? What is this? What is this nonsense? What have I done? Yeah, this is nonsense. Oh, I know what I was doing. Okay. This is wrong. Okay, so I have to change it anyway. So that's fine. So one thing at a time. Let's go back to type diff. There we go. I'm gonna need to handle a few other cases. I'm gonna go back to this window so I have a bit more visibility. basically, I want to handle all the possible cases. So So if I have two top-level declaration N1, top-level declaration N2, then I need to handle this, okay? So basically I'm gonna have to do the cases myself, is basically what I have to do. But I don't have to handle all of them, because there are several of them that only make sense in a value context, and we are here in a type context. So I'm just gonna be built-in function doesn't make sense here. That can't happen. Type parameter t1, type parameter t2. And all of those are going to be basically the same, but I have to handle them nonetheless. What do I do with placeholder? I guess... Oh, also this is going to be with a comma because I'm doing this curried, so uncurried, so this is going to be a tuple. There we go. Placeholder. Placeholder. And function pointer is the last one. Function pointer. In any other case, including the ones that are impossible, I'm going to assume that they are different. And therefore, if I have a roll1, roll2, regardless of what they are, catch all case, I return. Well, actually, this is not... Actually, this is P1, P2, and I'm doing a case of path name P1, path name P2. If it is literally anything else, I don't have to match the name. It is indeed P1, P2. They are different. That's the diff right there. And all of these other cases I have to handle based on the top level. So I guess if they are the same, it's nothing. Oh no, if it's not... Okay. So I think for all of them, it's basically... Okay. If different is this, if similar, it's this. I'm not sure if different, if similar is a great name for this. I guess I could just different similar. So now I can do if t1 equals t2, then similar, else different. If built-in type T1 equals built-in type T2, then similar else different. Type parameter, if T1 equals T2, then similar else different. Placeholder, placeholder, similar. And function pointer is where things get tricky. Because here I have to do the same thing on the inner types. So if I look at my AST and I look at my function type, I don't have here. I am only doing a diff, so I think I can ignore reference versus value. As in, if the type argument is not the same, the type checker will reject the function in the first place, so I can assume that at this point I am only interested in, for a type diff like this, yeah, I think I'm only doing this for template resolution, so I think in this case I can ignore the kind of the argument. Okay, so this will be the type diff of the function arg type of the fun. Oh god, okay. So I'm gonna have the fun type arguments, fun type args of T1. And I'm gonna have the fun type args of T2. Which will contain some path info as well. So this is a map function type on this. This is, I can rewrite it as an operator. There we go. So I get oh, but this is making the assumption that they match in number. There would be a type error if they didn't. So I can assume that there's the same amount, which means I can. So I get the type of the arguments of the first one, the type of the arguments of the second one. That's a list of type. That's a list of type. I can zip with type diff. So I'm doing a type diff of all of their arguments. That gives me a list of lists of tuples of differences, and I can concat that. So that's the difference in the arguments plus another thing, which is the type diff between oh god. This is going to be a fold of a lift A2 type diff of the fun type return T1 and the fun type return T2. Okay. What a nightmare. This is unreadable. This isn't readable. Let me rewrite this, I think. So args f args1 equals this. And I'm going to write it with the map for readability. There we go. F args2 is, or just args1, args2, I don't need to. It's obviously a function given the context. It's this but for t2. Return 1 is oh, actually the lift a2 is wrong, because I want to do a from maybe of this with unit type, I believe. If I look for unit type, from maybe unit type, yeah, okay. Because I want to be able to say, oh, on the left-hand side it says T, on the other it says I don't want to do the comparison only if both of them are saying giving a type, so this is better. And so the result of my function is I concatenate zip with type diff args1 args2 plus type diff return 1 return 2. Okay, that's a bit more readable. This removes the requirement of comparison on a roll, which is better. But there's another place where I'm doing something completely absurd and I have to fix now, which is in the comparison of constant values, which is this there. I have in this gigantic helper function for dealing with an expression within a constant value, I have at some point, I make here a comparison expression thing. Compare expressions, comparison expressions. Yeah, I'm just applying equal to a random expression, which makes absolutely no sense. Because I am at compile time, I know the value, therefore I can rewrite this. It will be a bit more verbose, but I can rewrite it as for all a ord a as in a comparison function that works for any type that is ord. And I will want the same thing here, but I think this is for equality. Compare expressions and comparison expressions. Oh, why is that all commented out? Wait, this is not used? This is not used? I have binary int expression, binary. I have comparison expression, and I have binary bool expression. This one is not used. Oh, wait, it's used here. I'm an idiot. Okay. Okay. Yes. Okay, so the comparison expression. I check the types, of course. Okay. And then I create a Boolean expression that contains this. And this is where I do the check of the actual underlying values. And here, instead of doing this, I am going to have to do I'm going to have to match all possible cases. I have already checked that the type match. Which means actually I was gonna say I can just do int comparison. I don't think that's true. Not all types will always, all literal types will not always be a int. So I think I need this for all that I have at the moment, because at some point I will have support for lists, array literals, and string literals. So no, I have to do this nonsense. Okay. Is it possible to have types that match, but not the same expression underneath? I don't think so. So here I can just do here I can do an error because I only call this thing, which actually, since it's only ever called here, I should inline it instead. I should inline it instead. So it always happens after having done. It always happens after having done the type check, so I know the types are the same. Although I guess I don't have to do that. I could just. No, I need to both. I need to do both. I need to do both because the types, the representation could be the same, but the types could be different. Can I rephrase this in a way that avoids having an error branch? Can I avoid having an internal compiler error branch that I don't want to keep? No, I don't think I need to handle. Yeah, okay. I don't think I can do that. So when the types are different, I do that. Then I do result is this. I had it as a separate function because I need to go recursively on structs. Okay. Wait, I'm doing type equality there again, which I don't think I can do. I think I have to do an unless type matches. I should not be using equality on types. And then I do compare expression with this thing. Okay. That should be better. There's no need to do a pure. This is not in the monad. Okay. Am I missing anything here? I think I would like, when this compiles, to remove equality on most of the AST types. Parser in pattern, yes, this is a tuple, not two different values. There we go. Okay. No instance for EQ role. I'm using a Okay, so yeah, I think I want to remove all uses of equal equal on types. It's too risky to use it. It will be wrong in some cases. It cannot be done properly. I have to do this the proper way every time. So I have to handle all of those cases. Except I have fewer things to handle because okay, I will be able to say arg matches is that, which will be only evaluated if needed, thanks to laziness. Okay. Perfect. So, top level declaration T1, top level declaration T2. If they're the same, then they match if T1 equals T2. Built-in type has already... We've already handled the case of void, but otherwise it's just T1 equals T2 as well. Type parameter that is just they are the same, otherwise no. Placeholder has already been handled. Well, I think type parameter has already been handled. Type parameter is always true because it depends on the instantiation. So I can't check at that stage, so I need to do that. So the only one I have to handle is function pointer, and otherwise it is false. So this is this, and arg matches, suppose. Built-in type, I will test for the args just in case one day I have a built-in type that has type arguments. And now, for two function pointers, if, so I get the function archetype of T1, function archetype of T2. Wait, do I need to do, yes, I need to do that. So I get the types. Oh, here, however, I will need to do, I will have to check that the type matches, as in, I will need to check that the type of the arguments are correct. Because if they're not, that's going to be a problem. So here I can't do that. So here I might want to introduce so I have two arguments, 1 and 2. And that's going to be a basic query of case of if they're both by value t1 by value t2, the answer is t1 type matches t2 if they are by reference. Okay. And otherwise, that is false. Okay. So now with the args, I can do and of zip with check args of fun type args t1, fun type arg t2, and type matches of return 1, return 2. It's a bit ugly, but that should be a lot better. I can't compare expressions. Couldn't deduce or the A. Oh yes, this is comparison expression. This is both ORed, not EQ. ORed implies EQ, so for the equality ones, that should be fine. Okay, I have there again a use of the comparison operators on roll, which I shouldn't be doing. What is this? This is... I can probably get by with the type matches now, but just to be sure, this is the addition expression in the context of a constant, okay? So, unless type matches, error, wrong type, okay? No instance for EQ roll, unless type matches. Okay. And that seems to compile, which means I should now be able to finish what I had started. I'm gonna go back to name. Okay, I did clean the comments, perfect. I'm gonna go here and I'm gonna remove egg and ord here. I'm gonna remove egg and ord here. Do I have any other that has EQ constraints? Typed expression. I think I want to remove that. Function archetype. I want to remove that. Oh, I hope this doesn't break anything. Okay, so why do... Why would I try to make them hashable? I don't think I want to keep that. No, okay, path info needs to be... Does it need to be hashable, though? Do I ever use a path info as a key in a hash map? I don't think so. Okay, we'll see. We should be close. I don't use it in a hash map. Okay, I can probably remove all of the EQ constraints now. They're never used. Perfect. Goodbye, good riddance. Okay. We still... What can I test? Because with all of the changes here, what can I test? Because we haven't extended the syntax of absolutely anything, I cannot test any new syntax. And we don't have automated tests because we still have nothing. But I guess I can uncomment this, which compiled last time, and make sure that it still compiles now. So if we look at this nonsense, I think everything else is commented. Actually, I'm going to uncomment all of this because I want to check that my struct resolution still works in the constant. So this is a Boolean constant that constructs an S3 struct, which is this with a t parameter, so then an x of type t, not giving the type, so implicit typing there for the struct, where the type of x will be inferred from the fact that it is constructed from the struct S3, and so on. And here, to be sure, I'm going to also add a placeholder to make sure that also works. And then that's a character. So then I do .x.x.x to get the field x, x, x here to get this character. And I check whether it is equal to that S2 thing dot y, which should be true. Error multiple declaration foo. Indeed, I have a function foo here, and I have a const foo here. Let's remove this one. Multiple declaration of S0. Yes, that's correct. Warning, name shadow top level declaration T. Oh, yeah, that's correct. Wait, no. No, that's incorrect. Oh, no, I have something named T here, and it's claiming that it's shadowing something. It's shadowing a type parameter T. That's an error. I don't have a type parameter T in scope. So this const should not... Oh, wait, is it the other way around? Let me check. Analysis core. This would be in warning shadow. If I'm correct, I look at the type parameters, set type parameters. Yeah, okay. Warning name shadow. The first would be the list of names that it shadows, and then the one that is being... Okay, so... yes, this is a list. This is a non-empty list. So the thing that is being shadowed is the thing named T, and what is shadowing it is the type parameter T. Okay? And that is in the definite declaration of oh, I don't have the context for which declaration it was. Okay. That's a bit annoying. But this was... So I have a situation where a type parameter T here shadows a thing named T, and I probably have it twice. Okay. I have it more than that apparently, even, because I have it here, I have it here, I have it here, I have it here, I have it in a bunch of places. Okay, but those are warnings, so it should be fine. But I have an error wrong cast where it's a boolean and a character. Yes, I have forbidden casting from boolean to character the other day because it makes no sense. So this is wrong, and if I remove this, I will get all of my shadowing warnings off. And okay, so now this compiles. And can I check that this Z with the placeholder thing here? Actually, I'm gonna try putting a placeholder here. It's an S3 of placeholder. That still compiles, perfect. And Z is a constant whose value is true, because this character equals this character. So this still works. Okay, so we haven't broken anything big. And we have removed equality and comparison things on things that shouldn't have them because they're too complex to be to have an absolute always true thing. Because again, like placeholder and other things like this will mess up equality. So we've removed equality from types and roles, and from most of the AST, I think. We have started splitting the code from this gigantic file, which was 1200 lines when we started, is only 800 now. So we've managed to make some cuts there. The big thing we have accomplished this evening is this context file, which has I didn't actually document them properly. Check whether. I'm gonna remove this because it's better to have nothing than having something that is wrong. But at least we have harmonized the names of those functions with like type or value explicitly in the name, lookup versus resolve versus check. We have added a bunch of checks that were missing. We've deduplicated the checks by making use of common functions. Like for instance, resolve struct type is just resolve type into check struct type. Okay. We've added function pointers. We've just added function pointers this evening, despite the fact that we don't have any syntax in the language for functions as arguments. We don't have function types. But now if someone does let x equals print with print being a function, that should work. Which, cursed, but that's fine. And we have rewritten all of this to make a difference between type and value. Okay. And with a big change, which is that now this module only exports a small API, so we have moved a bunch of things to a dedicated folder, which is progress. Yeah, I started wanting to okay, I'm just gonna move the code around and document things because it's better for the code to be more readable. I did not end up writing as much documentation as I was hoping I would, but I did fix some bugs, so there's that. And the code is definitely a tiny bit cleaner now, but yeah, I definitely need to write documentation. So again, regarding these questions of should I write documentation on stream? Should I write it off stream? Should I wait until the Moon project is more advanced? Should I do it now so that the code is readable for people who just jump in? Let me know what you think on Blue Sky or Mastodon. And yeah, I guess I'm gonna stop here for this evening. It's been oh god, it's been more than 6 hours. Oh wow. Okay, yeah. I should absolutely take a break, go have some dessert, and then go sleep. Thank you everyone for tuning in. I hope you had fun, and I'll see you all next week.